This?
I'm talking on the mic.
Let me give you some level.
Testing, testing.
You okay to throw my stuff? And go.
Testing, testing. Hi, I'm on the mic. My name is Bert. I'm going to be doing the commentating here over at the
You
RobotX.
have it turned on? There's a switch on.
Hi, 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 hi. Oh, wow. So it's going to go over the mics? I mean, the speakers? Oh, that'll be fun. I get to listen to
I just do
myself.
that.
That's why I like to have some headphones.
You know what? It's grade 0 from the trailer.
Oh, okay.
Or Diet
And the
Coke.
second
Anyway,
mic, please.
hey, Janelle, how's it
Would you
going?
talk in the second mic as well, please?
Diet Coke or grade 0?
Just say mic 2.
Mic 2. Oh, this is always on? This is an always on mic.
Why I'm here.
Hey, well, I guess he's going to be monitoring the audio throughout this entire competition.
can you copy?
We will start in just a few minutes. And so if you're on the live cast, that's great. Stay tuned because we are starting in just a few.
You guys are working together. Extra radios, Martin?
Oh, so you want us to tag or specific option? Okay.
Wow, that's a very good point. Here's Julie.
I'm
Amir.
right here.
Not
Yeah.
Julie. Hey, Bob.
Say my name.
Right here.
We good. Right now the water? Yeah. Yeah, it's right there. Okay. I'll try. I'll do it, but no, I'm not stopping. Oh, this is not good. Yeah, yeah. So because I gotta stop. Oh, that's what's easy. Okay. These don't have to handle them.
You wanna, should we start talking about the team, or you wanna? Yeah. Welcome everybody to the Maritime RobotX Challenge, and we're getting ready for the first heat of the afternoon, right? And we've got 5 teams that are in the finals. And right now what we're going to be doing is giving you a little background on the first team that's up. And this is a team from Taiwan. And I've got Eric here. He's an embedded judge. He's actually spent probably the better part of this whole week working with this team, observing this team, and kind of going through the qualifying rounds, right?
Yeah, that's correct.
Yeah, so tell me, Eric, what was that whole experience like?
So this is, like you mentioned, this is their first time to attend the RobotX competition. They showed up early in the week. They got their boat assembled and were able to get out on the range. The first thing they have to do is prove that they have autonomous control. Mm-hmm. So we have a navigation channel. They have to be able to make their way through that autonomously, and that just proves that they have a boat that responds to their control system. And then they proceeded to gather data for a couple days to calibrate their sensors and do those things. So by Wednesday they'd only qualified on the first challenge, but then Thursday came around, and in short order they just went one after another and got the next 4 they needed to qualify.
Wow, that's pretty good. And so you said this is the first time that they've participated, so they didn't participate in 2016?
They are new this year. They did not participate in 2016. So they're actually the only team to qualify for the finals that's new.
Wow. So in terms of their developing of the team, in Taiwan, I mean, they must have done a lot of kind of focused work at home prior to coming here.
And they did do a lot of focus work at home. They have a modeling system, so they're able to model their design and do it in simulations to kind of prove out that their code will work, mm-hmm. That their system architecture is feasible, and then they start integrating it with a non-maritime vehicle. And finally, they move forward and integrate it with this vehicle.
Do you know the composition of the team? Like what sort of students are part of that team that put together this particular system, this boat?
I believe it's primarily computer science and electrical engineers.
Do you know if they're like undergrad or graduate?
This is almost entirely an undergraduate team.
Wow, that's great. Okay, so what are they doing now? What is their first task that they're undertaking?
So the first task, they're searching for a beacon, mm-hmm. and there'll be a beacon that's active between one of the 3 gates. So we have a gate between the red and the white. We have a gate between the 2 white buoys, and then one between the white and the green. They've just gone auto, so their run has started now. When they identify which gate to go through, they're supposed to proceed through the gate, and you'll notice that there's a just a moment here. You'll notice there's a flashing light on the beacon, and what they're trying to do is read the flashing light code.
Green, blue, red. Green, blue.
It's flashing.
I see. Yeah, the buoy out there. I mean, it's red, green, blue, and the vessel is actually in autonomous mode right now. So there's no remote controlling that's taking place.
That's correct. So there's a green light on the top of the vehicle, and when that's on, that means that they're in autonomous mode. Their remote control, they don't have their hands on it. They don't have their hands on their computer. Their software is doing all the work on its own.
So tell me what again is the task that they're actually undertaking right now? They have to circle that.
Yeah. So what they want to do is they want to approach the light tower, read the colored code. They'll report that out on their computer screen. They'll report what they see as the code, and then they need to circle that light tower, and then they can head off to one of the other challenges.
So they've already completed this particular task?
Looks like they have just shifted to radio control mode, so I think they just aborted that run. So we'll look for them to reset here and start again.
Okay. So they actually did some attempt of the task, and then they decided that they couldn't do it, and then they're correct. Well, are they going to start?
Yeah, they're going to start.
Oh, okay. I was just saying that, we were sort of, doing a play-by-play, and then those guys were like...
Yeah, no. They're judges. They're actually judging that. I know. They're judging that task. So they moved a little bit, but I didn't want to interrupt them while they were trying to watch the actual
Yeah, I know. But it's going to be challenging if everybody's standing in front of theirs.
Well, that's why we were going to have the screen over there, but to help you see. But it's actually easier to see in real life, I think, than it is from the video.
You have any indicator to get them over where they need to go? No, I do not. They come over here by Team Village. Do you manage to get there?
Trainer mobile.
So which one was this?
Entrance and exit.
Oh, okay. So they actually entered and exited, right?
Correct. Well, they entered and then they went to radio control mode to they're still positioned in radio control mode right now.
Hey, can you tell your sister with the camera to keep the camera mostly on the vehicle that's actually on the course as opposed to on the people?
Okay.
Thank
The
you.
gate is
So
one.
how you doing?
The buoy
Right.
is blue.
Okay, good.
The vehicle that's in the bottom left of the screen right
It's
now.
great to have you on because, from a subject matter standpoint, you know the details. Right? I can kind of commentate kind of in a general sense, knowing the specifics.
You read the rules like you see it in actions.
And then, knowing since you're a vet enemy, you know exactly what you're attempting. And it's easier for me to pull that out of your mind.
Are they attempting again?
Yeah.
Over.
All right, so the team has now gone into autonomous mode, which is basically they are letting the vessel do its thing, and they are repeating this exercise. And I guess what? They have to go through the entrance and the exit.
Yes, the goal is to enter through the gate that has the active beacon, and at the end of their run to exit out of that gate. Looks like they're going to abort this run as well. They
Right,
got hung
and
up on one of the white beacon buoys there.
And so just observing what it is that's happening right now, I mean, they went into the gate, but they actually touched one of the buoys, and it's probably not exactly the task that needs to be done, right? So, in fact, I don't think you're supposed to touch any of the buoys as a result of this particular task.
No, that's correct. NCTU this morning, actually, in their practice rounds, they found a problem with one of their motors. So they have a new motor on. They just put it on before the final round here. So, perhaps they're dealing with a little bit of calibration issues there, and we'll see how they get in this next autonomous attempt.
Now, in these final rounds, what they are actually attempting to do as many of the tasks as they can, and they have about half an hour to complete as many as they possibly can. So they have as much time as they want to dedicate to this task, but at some point in time, if it's unsuccessful, they have to probably move on to the next task.
To enter the course and start a run, they actually have to go through these gates. So this one they can't skip.
I see, okay. So now they're actually in remote control mode, and now they're going to sort of restart the actual attempt to go through this task.
Yes, that's correct.
Queensland University of Technology. They participated last time.
Well, it's a beautiful day out here right off Sand Island. And, you know, the days leading up to the actual finals were pretty testy. I think the first part of the week it was raining and windy. And I think all through this entire week it's been pretty windy. But the wind is still, you know, still something. But I think the weather has become sort of perfect Hawaii weather. This is our typical winter weather. And I think everybody here, I don't see anybody, well, I have long sleeves on. I mean, I think I'm doing long sleeve because of the sun, but, you know, there's not too many people with their winter coats on, I think. So this is the Maritime RobotX Challenge, and we're in the finals. We are watching the team National Chiao Tung University. They are from Taiwan, and they are getting ready to do their first task here. So we'll give you the play-by-play as soon as they go autonomous. Oh yeah, okay, so they're on autonomous mode and they are attempting to go through the entrance gate. Eric, how are they doing?
Looks like they're lined up for one of the white buoys. We'll see if they make a course correction in time.
So that's probably not what they want to do.
Now they're going back into manual mode.
Okay, so now it's back in manual mode. Now the task really involves going through, I think, those two white buoys, which is really the entry point, right?
That's correct. They need to go between either red and white, or white and green.
And how do they determine, I mean, which arrangement do they go through? You know, red, white, white, green.
So between each gate, there's a beacon that is reset randomly for each run. So they need to determine which beacon is active and then automatically adjust to go.
So depending on the sequence of the colors that are being displayed on that beacon will determine or basically tell them which arrangement or which gates to go through.
Actually, there are underwater beacons between like the red and the white buoy. The flashing code on the light tower is independent of that.
Is it just primarily for alignment purposes? What's the purpose of the colors on that beacon?
The colors on the light tower, they need to read those to prove their ability to do that, and then it helps inform later events in the course.
Okay. So now they're still in manual mode and getting aligned up.
Okay, they're autonomous right now. They're going through.
Okay, we're in autonomous mode and it's made it through the entrance gate.
Yeah, gate number 2.
Now, at this point in time, they are attempting to go around or find the exit gate.
At this point, what they should be doing is going to the light tower and scanning the code. I just heard some cheering over there, so I'm hoping that's good results on scan the code.
Okay, so the scan the code exercise, is that another task, or is that part of this entrance exercise?
It's part of, you enter and you scan the code, but there are points for each.
Okay. So the exit, okay, so entrance and exit is not part of the same task. I mean, this is entrance, and then they do another task, and then the exit.
Correct.
Okay.
Correct. So it looks like now they're moving over to the obstacle course.
Okay, so great. So they actually completed both the entrance and the scan the code. So now this is like the third part of the set of tasks that they have to do. And going through the obstacle course, are there specific ways that they need to go through the obstacle course, or is there is it up basically up to the vessel itself?
The teams have a couple of options on how they set their vessel up to do this. One way is to go diagonally from one corner, one white buoy in a corner to the opposite white buoy, and along the way avoid the black obstacle buoys. Another way is they can mow the lawn, so they can just kind of go back and forth across the side of the course, and that's a higher scoring way to do it if they mow the lawn several times.
We've got a couple of kayakers going through the course right now. I don't think that's not part of the exercise, right? They don't need to avoid the kayakers.
It's not part of the exercise, but we sure hope they avoid the kayakers.
Now, as far as going through the obstacle course, if they touch the black buoys, I mean, is that a points off of their performance?
Yes, there's a minor point reduction whenever they if they contact a buoy.
So now, are the judges that are actually judging this exercise, are they able to determine whether the buoys were touched or not, or is that something that on the vessel itself there's some sensor that detects a contact?
What you'll notice is that we have the judges here on shore, but then we have a couple judges that are out in kayaks, and they're positioned so that they have a good view of where the vessel is relative to the black beacons, and they are going to report back if they see any contact.
Okay, so all the judges here are actually in contact with the other folks that are monitoring, that are on the kayaks, and we can sort of see them on the left-hand side, and these are part of the team, the RoboNation team that's judging the entire event.
That's correct.
So in terms of the team and their performance through the obstacle course, what's your take on it? Are they doing the lawnmower, or are they doing the diagonal? It's hard to tell.
So they've really, at this point, they've gone up the right side, and now they're kind of working their way across the top of the course. So it's really up to the judge's interpretation of their route, and whether or not they've stayed in the course and on the upper side or exited. So, given that we have people out in kayaks, they're able to provide that feedback and really see what happened. It's a little harder to tell here from shore.
Mm-hmm. So if the performance was, a diagonal, you could actually see them going through the course as a diagonal. But now it's sort of up to the judges to interpret or value, give some grading to how they're performing. So what's happening right now is that they've actually gone beyond the obstacle course. Would that be, let's say, a completion of this task?
So it could be completion of the task, or they could turn at this point and go back through the obstacle course. So we'll really need to watch and see what the vessel does from here.
Now there is a limit to the actual course, right? So the course would normally be kind of where those white buoys are, and to the right of that. So the vessel is actually kind of gone beyond the course. staying in the vicinity of the.
Yeah. So what'll happen, when we're talking about a diagonal line through the course, when they sense a buoy, they avoid that buoy. So they can end up having, instead of the paper going like this, they can end up doing this. And they end up avoiding obstacles all the way over to here. So it's not a true diagonal, but that's because they're responding to obstacles. And that's where the judges are really looking to see, did they exhibit obstacle avoidance characteristics? They can see something and then turn and move it.
Now, as the vessel goes now sort of outside the limit of the course, do they have to bring it back into manual mode? Bring it back? I mean, what's in the course? Is it all
If the green light's
RC mode. NCTU manual mode.
Looks like NCTU is just transitioned to manual mode.
So what's happening right now is the vessel has gone kind of beyond the course, and now it's going into manual mode to retrieve it, to get it back into the course. Now, once it gets back in, do they position it for the next task, or what's the protocol, I guess, to proceed?
So the protocol for the next run, they have to come back and do the entrance gates again. So they could come back, and if how much time's left on their 30-minute slot here, they can go back in through the entrance gates and try again. And what they're looking for is the highest scoring run is the one that counts.
So once they actually enter the course, they're completely in autonomous mode, and they have to complete as many tasks as they can. If they, in this case, have gone beyond the course and they need to go into manual mode, they basically have to start all over again.
Correct. That task is, or that run is complete at that point.
I see. Okay. So the vessel is headed back to the beginning point, and once it gets back to that point, it's right now in manual mode. Once it gets positioned, it'll go back into autonomous mode and basically restart the exercise.
That's correct.
So, how will you know when their sort of time is up? Given that you're just sort of estimating, is somebody going to call out time's up?
Yeah, the course director will call Bonnie, will tell them the gesture hat on there.
Oh.
The woman with the gesture hat. She'll tell them time's up. They need to, at that point, wherever they are on the course, they'll transition to manual mode. It'll bring their boat back to the beach. So, and that will be so they have, at the end of those 30 minutes, they have a 5-minute period. Let's say 65 minutes to get out.
So, Janelle,
Yeah, Daniel's going to. So as soon as Bonnie calls it, he's supposed to tell her in 5 minutes.
No, it's one of the aluminum
Darren, they say they're going to go to docking.
We might need to go out there. Let's go out there.
This time they're going to go interpay, and they're going to go over to docking, attempt a docking challenge.
so when it's in that autonomous mode, how, like in the first one where they this attempt they went and they scanned the code and they went to the obstacle course. How did they change it so that now in autonomous mode they're going to take it?
So they basically have the code written specific to each channel.
So the team is still in manual mode, and it's still getting positioned, getting ready to try one more time to go through the entrance gate and complete as many tasks as they can. So what's happening right now? This is are they having a bit of a problem trying to align it up?
I think they're getting aligned for the next run. They just got a 5-minute remaining warning for this.
So now the that 5 minute is the actual designation of the completion of the exercise, or is this just 5 minutes more to the end of their exercise run?
Yeah, so they were allotted 30 minutes of run time. They've used 25 at this point.
Okay.
5 left.
So they've made it through. Now they're in autonomous mode. They made it through the entrance gate. Did they do the scan the code?
It looks like they're doing scan the code now.
So in scan the code, what is actually being done? I mean, there's some beacons that are communicating with the vessel.
So scan the code. You have the light tower that's flashing at you, and what the boat will do. There's cameras on there that will identify what sequence is being flashed, and then they need to report that back.
Okay, so has it completed that task, or is it getting into the position for some other attempt at it?
It looks like they have moved past the light tower, and they just entered the lower section of the obstacle course. And now they're headed out of the obstacle course. So we're going to watch and see what happens.
Okay. Because usually if the scan the code was completed, you'd hear some cheers from their from their team location here back in the booth here. So we're all waiting with bated breath. What's the next move?
Exit gate is 3. Exit gate is 3.
So we just heard someone say exit gate is 3. What does that correspond to? Is that an indication of where they need to head to actually exit the course?
That means the active underwater beacon is in exit gate 3, which is between the white buoy and the green buoy that's closest to the beach here. So as we go from left to right, gate 1 is between the red and white, gate 2 is white and white, and gate 3 is between white and green.
Okay, so whatever the vessel is doing right now, it has some amount of time to complete whatever task is being attempted, but then when they exit, they have to go out through the white and green gate.
Correct.
So they are attempting the obstacle course, and as you described the obstacle course, I mean, it's a pretty complex thing to actually do. I mean, it's one thing to avoid the buoys, but it's another task to really stay within the obstacle course, right? I mean, you can avoid the buoys by just going somewhere else where the buoys aren't.
Right. So getting through the course, when they do approach a buoy and they turn around it, their goal is to get back onto their planned course across the field.
Yeah, so this is, I mean, it's interesting for us to decide, which course. If we were on a kayak to go through the obstacles, we would look at where the buoys are and just avoid the buoys. But to actually tell a computer, okay, avoid those 2 buoys and continue on the course, then you might think from a program standpoint, the easiest thing to do to avoid buoys is to go away from the entire field of buoys, right?
Right, but they've plotted a course to go across, so how can they accomplish that while avoiding the buoys that are in their direct path?
Right, and that's where the the intricacies of the program and developing the application that actually guides this vessel through this in an autonomous mode. I think that's pretty fantastic.
It is, yes.
Navicheck Bravo, please go on Honolulu. They are stopped.
So it actually looks like Chiao Tung their boat has become entangled on one of the black buoys. We're going to see them, the support craft, come over and unentangle them.
And maybe to say a few words about the actual propulsion system that is powering these vessels. What's actually is it battery run? Is it solar powered? What's actually propelling these vessels?
So for Chiao Tung, they have trolling motors like you might use on a fishing boat that are powered by deep cycle lead acid batteries. Other teams have similar propulsion systems. Some are different. So as we go through the day, we'll get to see a variety of different propulsion systems in use.
So they did get kind of tangled with that buoy out there, and what we're looking at right now is the another support vessel that's there to kind of untangle it so that they can retrieve the boat.
That's correct.
So when they kind of did the cheers, I was kind of just celebrating the fact that they actually gone through. So this guy that's gonna join us, what year is he in?
Hey, John, good question. If we're
So I mean, like.
Oh wait, sorry.
I want to welcome Daniel, who is from the team from Taiwan. They're the National Chiao Tung University, and Daniel, you're part of this team. What year are you in college?
So I'm into electronic engineering in college, and then we had the chance to do like this kind of scale of competition. So we're really happy that we could build a great robot. This is the first time we did this, especially in marine. So we're really proud of it.
And you're a senior?
I'm a PhD student.
Oh, PhD. Okay,
Yeah.
so you're okay. Great. Yeah, I was told that you're a senior, so I'm sorry. You're a PhD student. Okay,
yeah.
great. Now, in terms of this team, tell me a little bit about the team. What is it comprised of? Who are some of the other students? I mean, they're all kind of standing around. Give them a shout out here. Like, are they computer science, electrical engineering? I mean, what do these guys do?
Hi. So most of the guys are from electronic engineering, and some of them from ocean engineering and mechanical engineering as well.
So tell me, we were kind of doing the play-by-play as far as how the vessel was actually performing. Can you give me a sense as to what were some of the challenges that you faced?
For the final round, actually the gates are really tight, so our boats fail to like turn in before we get to detect the gates. So that's why in the first few runs, it's stuck. So later we like adjust the threshold for that. We pass through. And the other thing is that the obstacles are really tight. So we couldn't find a way through it. So like we wander around and then find a way like further to the ocean. Yeah.
So I understand that I guess the system that was providing the navigation or the determination of where the vessel was, you guys had to kind of improvise, right? I mean, I heard that you had to put a cell phone on the the vessel.
So in the second day, we found that our IMU broke, so we had to like replace them, but we couldn't get one from local stores. So actually, I put my cell phone. It's my cell phone. So then I use Wi-Fi to send the IMU data back to our main computer as our heading.
Well, you should get a prize for some innovation there.
Yeah.
Now tell me, so you were able to go through the first entrance gate, and then the first task was the scan the code, and then you went to the obstacle course. I mean, that was a challenge too, right?
Yeah. So one of the challenges is that we have to transfer through different tasks. So that's the main problem for us, because they like swap the courses around for the finals today. So we have to like do live coding right here. Yeah.
Well, I'm proud of your team, and I'm hoping that you'll be here, in the next competition. So you guys did a great job being here for the first time and actually getting into the finals.
Yeah.
So congratulations.
Thank you.
Yeah. Thanks.
Thank you.
Hi.
Martin is subbing in for Stephanie Davidson.
Okay, Martin.
Yeah.
So Martin.
Stephanie Davidson was their embedded judge. She has been holding their remote for the stop, and I think that she's feeling a little superstitious. So
she wants to just continue to hold it.
The way that they've been running all week.
Okay.
So she's briefed Martin. Martin was with them
and I've been
during.
hanging with them all day.
Yeah.
Okay.
So he's been doing practice runs with them all day.
So
you're in the sun here though.
Oh, yeah. Sorry.
But there's not much we can do about it, huh?
Not much. No.
It is life.
It's going to get worse.
It is. I'm wondering actually hang on somebody other than Mia or Bonnie. Like.
All right, so we're going to start the next team, and they are from Queensland University of Technology in Australia. And I've got Martin here, who is one of their sort of embedded judge. So tell me, Martin, give me a little background on this team.
Okay, so I guess the first thing to say about this team is they were actually the best team first 3 days of the week. So Monday, they were the first in the water. They were the first to actually qualify for the semifinals. And then they also went ahead and did all tasks except the underwater ring, so 6 out of 7 tasks.
So now they pretty much, they're in autonomous mode. They went through the gates. The entry gate, I guess, was the white and green. What are they currently doing? Did they do the scan the code?
Looks like they did a scan the code.
Okay, and so now they are going on to their next task.
Nope, because they just switched to manual. So they're resetting because I think it started wandering a bit further away than they expected it to. So, but they are listening for that underwater beacon. So they were doing a pretty good job of finding that this morning.
Okay, so they're in manual mode right now. They're going to actually come back and restart.
Yes.
Okay. So Can you tell me a little bit about the team? I mean, they've participated in the RobotX challenge for a number of years, right?
Yeah, I'm not entirely certain if they were here in Singapore, but I know for sure they were here last year. They're saying that yes, they were here on all of the years.
And in terms of the composition of the team, what sort of specialties are the student team members?
I'm not entirely certain for all of them, but most of them, the ones that are here, are a lot of their programmers. Handling a lot of that. I'm pretty sure they're supported back. They're involved with their computer vision laboratory.
Do you know if how big the team is?
So the only guys here, there's 4 students and then their faculty advisor.
Wow, that's pretty good.
So it's a much smaller team than many of the others. Physically here, I don't know how many are back in Queensland. So they've certainly had a lot of support, I'm sure. So it looks like they're starting their second run now. They just called out to go auto, and it just went blue. So there it goes.
Okay, so there's a little light on the vessel, and when the light is blue, is that when it's in autonomous?
Yeah, so when that little light just in front of the flag turns blue, it goes autonomous, or that's the indicator that it's autonomous. When that goes yellow, that's the indicator that they're back in remote control. And so you can see they called out, the beacon was underneath that gate, and it went over, and then it thought about it, and came back and drove through the right gate. So that's a good sign. Now it's looking at the scan the code.
Okay, so scan the code. They look at the lights that are on the the beacon in the middle.
Yep.
And right now it's like blue, red, green. Oh,
Nope.
Nope. Blue, blue, red,
I think
blue. Or is that? I can't see from here.
They just went to manual mode anyway, so it's going to change for the next run. It was green, blue, red. Yeah.
Okay. So is that?
Green, blue, red.
Okay, so
Dark.
oh, that's dark.
Green, so it's like.
I'm right here.
Okay. So I can't tell between the dark and the blue.
I understand.
We're alternating every cycle, so I'll be.
So here's another little tidbit while they're resetting themselves. Not only were they the first in the semifinals, they did great all week until Thursday, and then their batteries died. And when I mean died, it wasn't just like they ran out of energy; they actually went completely kaput.
So this vessel is battery driven, and you know the batteries that they have on the vessel. I mean, how long are they rated for?
That's a great question. I don't really know the answer to that because there's a lot of variations across all the different teams. Many of them are lithium with various chemistries, or they're actually using lead acid batteries, which are rated for a long time. But how long they hold their charge is another issue.
So you said that the batteries went dead. So was it a big drain, or what caused the batteries to go go and die?
Unfortunately, all I know, it was just pretty much a catastrophic failure. So they're running.
Run number 2.
So they're autonomous again, and apparently it's on beacon 3. So it wanted to go through 2, but so here's another tidbit. Their vehicle's named Bruce. So when I say, hey, Bruce decided not to go through the middle, and now they just went back to manual. So they took Bruce out of.
I was
autonomous.
One of the tasks that all the teams have to do is produce a video, and I got a chance to watch many of the videos, and I remember. I think this is the only one that has a name, Bruce.
Perhaps, yes.
I'm glad they didn't pick Bert.
So they do call him Bruce, and they like to refer to him quite well as, hey, is Bruce on? Is Bruce working? What's Bruce thinking now?
So once Bruce goes into autonomous mode, it's really just Bruce doing its own thing.
That would be correct.
Okay, so now it's kind of restarting, right? So it's still in manual mode.
Yep, they just requested to go to auto, and I think it's hard to see it, but I think the light just went blue.
Okay, so it's now
back in autonomy mode.
Now in blue. It's got the gate that it's got 2 entrance on. That's the white and green. And they're going to attempt to do the scan the code.
Yep. So they'll do that next, and they usually turn and face the scan the code when they're scanning it. So we should see that in a moment. Oh, but nope, they just went back to manual. So I think what happened that run was they for some reason it didn't figure out that the scan the code light tower was the scan the code, so it started looking for something else probably. But it's Bruce. We
Well,
don't
you know,
really
that's interesting. So the light tower, I mean, we can see the light tower. We know where that is. So how does the actual vessel, what kinds of programming is part of the system that determines the light tower?
So with most of these boats that are out here, they're using LiDAR as a sensor to figure out where all the buoys are and what all their shapes are. By the way, they just called out that they're going to go auto again, so they're starting their next run.
Okay.
And then they'll use a video camera and do a lot of image processing on that video stream to find things like the colors on the light tower, the colors of the buoys.
Got it,
and
right.
things along those lines. So it looks
Okay.
like it's choosing the red and white gate this time.
Now, did they get some indication that that's the right entry gate to proceed through?
So at their judges table, they have a little indicator that shows where Bruce heard the hydrophone or the beacon. But watching where Bruce goes is also a pretty good indicator on where it thinks it should be going.
Okay, so now it.
So it just scanned the code, and I think it's done.
Yeah, went to the light tower.
And
I
it's
hear some
moving on
applause, so
around. Yep.
that's a good sign.
And then usually they go to the obstacle course next, but I'm not sure if that's where it's going to go. Or no, it's turning around. It might be still scanning the code. No, nope. It was just doing the circle.
And you
around
mentioned LiDAR. LiDAR is like a kind of laser-based radar system.
Yeah.
I mean, it's a detection system that it sends out a light, it retrieves it, and it can determine, does the signal processing and understands what it is that it actually returns signal with.
Yep, that would be exactly right.
So now it's headed to the obstacle course.
Uh-huh.
And what is your guess as to what path it's going to take? Is it going to go a diagonal? Is it going to do a lawnmower type of?
I'm going to guess that it's going to do a diagonal path because it seems to be headed to that leftmost corner.
Okay.
And this morning when they were doing their practice runs, they tended to settle on a diagonal path, and it would actually move pretty quickly through there. This might be one of the faster boats in the
this boat
field.
is pretty fast. I mean, it just definitely gets into position, does a quick turnaround, and now it's just zipping through the obstacle course. That's pretty impressive.
Yep, there it goes. And it's aiming for that white buoy that's out there in the far right corner of the obstacle course from our viewpoint.
Well,
And
I
it
hear
looks
some
like it's
I hear
doing
some
great.
applause, so that must be a good sign.
But Bruce is turning away from the white corner, so they're not sure. Maybe it's just dodging a little buoy there. Oh, yeah, it was going around that little black buoy, a different route than they thought they would.
Now, is that a point getter, or
Yeah, so traversing the obstacle course like they just did definitely earns them some points, and they clearly went the corner to the corner. At least it looked like that to me.
That's great.
So now they're heading to the totem field.
Now they're doing a straight run to the totem field. And what is the task that needs to be taken there?
So they just stopped this run. So they're going back to manual. But since you asked about the totem field and we made it there, the scan the code. So if you look at the three colors of the scan the code, those are the three colored totems that it needs to be interested in. And so it's tasked, like for instance, if the scan the code went green, blue, red, then when it goes to the totem field and after it figures out which one's the green one, which one's the blue one, which one's the red one, then it's supposed to circle them in that order in various directions.
Ah, I see. Okay, so the light tower actually is an indicator for how they need to perform in this totem exercise.
That would be correct.
Okay, so now they're coming back. They're in manual mode, so they're going to actually restart the exercise. Do you have any ideas to what might have caused the vessel to, or the team needing to go into manual mode to bring it back?
So this is the first time it was in the totem field on this afternoon in this course, and so they some of what they were working on this morning was how well it was doing and what it was doing in the process of recognizing which totem was which, and particularly also the little path that they were planning to move around within the totem field to figure out which totem is which. So my guess would be that they decided to stop it because even though they're watching Bruce and they're seeing that, they're also watching their computer screens. They're not touching them or anything like that, but they can tell if after a little bit that the route planner, if it's like doing something that doesn't make sense to them, So sometimes they'll be, okay, Bruce is confused. Maybe it's better if we just stop and give it another go. So that's what they tend to do.
So the five tasks that the Queensland team were able to complete to qualify for the finals included which five?
So they did a good job of finding the beacon, scanning the code, traversing the obstacle course. Those were the three that they did the easiest. They did actually circle the totems in the qualifications. And then they detected and delivered. So that's shooting a wrecking ball into the square holes on that apparatus. And they also managed to dock. But I do know that they're feeling a little bit uncomfortable with their confidence in its docking ability, so they may not attempt to dock during their runs today. We'll see.
Now, I'm just curious, did any team do the retrieve the ring?
That could be a great question for one of the teams that goes later.
Oh, okay. We'll save that for later. But that, from what I understand, that's one of the most difficult.
It is the most difficult and to me the most interesting of the tasks. So they're now starting their next autonomy run.
Okay, so they're in autonomous mode. This is Queensland. This is the Queensland team from Australia.
And they should be going straight up the middle this time.
Okay, so the entry gate was the two white buoys. And they're headed to that light tower, and they're looking at it and determining what it's blue, green, blue.
And they're looking at it.
It's got to transmit that back to the team.
Yep.
I hear some applause. So that means they
so it just said it's blue, green, blue.
Good.
So now it's going to do a little behavior based on those lights.
Okay, so the lights determine a particular behavior, and what behavior is that?
So when the first light is red, then the vehicle should go past the light tower on the left. If the first light is green, it should go past the tower on the right. If it's blue, it should do a little circle around the light tower.
Oh, and that's what it's doing right now.
And so you can see it finishing the little circle.
Oh, that's very good. Oh, I hear some applause. Good job, Queensland. Now they're heading to the obstacle course.
Yep.
And from
probably straight over to that left corner.
Yeah,
again, like
that's what we saw the last time. So
one way many of these teams do is they kind of queue up the tasks. So they have a little bit of an order set in there, so kind of keep following the same mode as it goes through, even though it's doing it all by itself.
Well, that totally makes sense. That's what I do when I drive to work. I just go into autonomous mode and just drive to work. So the what it did the last time was it did a diagonal, and it went from basically one end all the way to the other end, but it did a little kind of roundabout one of the last buoy, right?
Right.
Let's see if it does that again.
Yeah, and it may not, because it kind of came into the field a little bit differently this time than it did last time. So we'll see what happens here. It's already a little bit different than the last time.
Yeah. It's actually taken a little different route than the first attempt.
Actually, looking at it, it may be possible they're trying a lawnmower. We'll see.
Now, the lawnmower path is more difficult than the diagonal, so that's a bit of a challenge.
Nope, it looks like it's just the diagonal. Well, maybe not.
Okay, so it went through part of the obstacle course. Now it's coming back through. Looks like
it is doing a lawnmower
pattern.
Lawnmower. Yeah. So they didn't do this at all this morning. I guess they were feeling pretty confident about it.
So again, it's in autonomous mode. So nobody's actually remotely telling it to do the diagonal. So it's already been part of the autonomous sequence.
What do you need?
So it's pretty impressive that they're attempting this diagonal.
Well, it really looks like they're doing the lawnmower. So they
lawnmower, yeah.
So they went on down, and now they do a turnaround on the far side, just like you would when you're mowing your grass, and then they're turning around and going back the other way.
So this lawnmower, pathway that they're taking, I mean, it's got to traverse this obstacle course probably about 5 times.
I think that might be to get the most points. Oh, but it's turning in a different way than I thought it would.
Yeah, I would have thought it turned right.
Although, I don't know if that matters. They're letting it go, so it's still driving.
So now this, again, this vessel is named Bruce. Bruce has decided that It's going to do the lawnmower.
Indeed.
Now, is it? It's got to go from one corner to the other corner.
Well, so as it does the lawnmower, you kind of want to see it go back and forth across at least a couple times. And so it looks like it might be just once, but eventually it wants to end up in that opposite corner. Again.
Now, when you do the lawnmower, I mean, does it have to go through a prescribed number of times, or can it do just 1, 2, 3 runs and then boom, it's out?
I think that's completely up to how they programmed it.
Okay.
So it could do less than 5.
Okay.
So looks like it's going for at least one more pass through though.
It's still successfully going through the obstacle course. Now, it shouldn't touch any of the buoys, right?
Right. So their goal is not to hit a buoy, because you lose points if you do. The little black buoys tend to be the biggest challenge when it comes to that.
The little
ones, not the big ones, because they're the hardest ones to see.
So what's going on in terms of the programming? Is it kind of determining what's in its field of view, and is it harder to detect? I mean, I would imagine that it's a little harder to detect the small ones.
Yeah. So that is what it's doing. It's going through, and it's kind of mapped out with its LiDAR all of those objects. And then it's also kind of, I think, based on the shape of them from the LiDAR, it may classify some of them already as obstacles.
So has it completed the obstacle?
Okay. So I overheard them say over there that it's they're
okay,
good.
great. So it's done with the obstacle course. Now it's heading over to the totem.
Yep. So we're going to try that again.
Now, based on what the light tower indicated, what is their task that they have to do in the totem exercise?
Yeah, so their goal now is the light tower is going blue, green, blue. So they're going to drive around the light tower, and I don't think it really matters if they run into any of those buoys, just so long as they don't run over them and get them caught in the vehicle.
So they have to circle the.
Yeah, and so their goal is, once they find the blue one, and even if they take some time and find all of them, I don't think that matters, but once they determine which one's the blue one and which one's the green one, they're going to circle the blue one, circle the green one, and then circle the blue one again, if they want to get their most points. And so it sounds like they might have just found the blue one, because I think it's doing a circle around it.
It's kind of gotten the buoy right in the middle of its.
Okay, so they just stopped that run. I think it's maybe running over the blue buoy was the problem there.
So they have to go around the buoy, not through the buoy. So it's back in manual mode. It's going to come back to
I'll do what I can, but
square one and start the exercise over again.
I hear you. There's too many of us.
yeah, I'm glad you recognized that.
So now that they've gone manual, they're going to have to drive the boat by remote control all the way back to here.
And basically start all over.
Yep.
So this is if you're tuning in to the live cast, this is the Maritime RobotX Challenge. This is the some people have called it the DARPA Challenge of the marine robotics, and it's pretty impressive. And this is something that happens every 2 years, and it happened in Hawaii in 2016, and we are fortunate to have it back here in 2018. So we're very proud to host this event. So the Queensland folks are coming back. They're going to start all over again, and I think they did a great job. But I'm anxious to see if they can make it through the totem field.
Yeah, I would love to see them succeed in the totem field. That was definitely the challenge they were working the most on today. And they felt like they had the aha moment this morning with their software. So
no, they don't have any. They don't have to worry about perhaps running out of battery, right? I mean,
not at this point. They're being a little bit cautious about that because of their catastrophic failure on Thursday. But they should have plenty of battery to get at least through the full half hour that they're allotted for this. And then the batteries that drive the motors and all that, those will last plenty longer. So it's really the computers and the power that they're using to run the LiDARs, run the video cameras, and run all the computers that are on board.
So when we were just observing the exercise with the task with the totems, and they were really required to kind of go around the totem. So I'm just curious, what would be the programming that determines and informs the vessel to actually accomplish that?
So many of these teams are using the ROS libraries, and so then it would just basically be like a driving. There's several ways to do it, but it would be essentially like a driving behavior or something along those lines, where it could do a little group of waypoints around it, or it could say, hey, this is a central point, drive in a circle a certain radius away from it. But that's all sort of in the path planning that they figure out within their vehicle.
Okay, so great. Well, we're still in manual mode, so they're getting lined up, and we'll start the commentary again when they get into autonomous mode.
Sure.
All right, so we're watching the Queensland team, and they are already in autonomous mode. They went through the entry gate. They did the scan the code, right?
Yep.
Now they're going to do the obstacle course one more time, which they did previously very successfully. So let's see what they attempt to do this time. I mean, they did diagonal before. They did the lawnmower. What do you think they're going to do now?
If I had to take a guess, I think they would do the lawnmower again, just to try to get the most points in one run. But the interesting thing is the path through the field might be different as they do this lawnmower pattern.
Yeah, that was an interesting. You would think that they would just kind of zigzag back and forth, maybe go about 3 or 4 times, but when doing a lawnmower, I mean, from a judging standpoint, what is the thing that gets them the most points?
So they're basically, it's the number of times they can go down and back is how they get the most points in there, but they have to be clearly going through the field. So
I got it.
So like
right.
the down can't be completely outside of the field.
I see.
Or
Okay,
the
so
back can't be quite
so
out.
you can the diagonal obviously is a way to go through the field and get points. but that's probably the minimum amount of points.
Right. But you're still successful at doing as opposed to getting no points for not doing the obstacle course whatsoever. So now it's turning around to do the back now. So it's done the down.
So this is sort of a modified lawnmower, or is it?
It looks a little bit like the last lawnmower.
Yeah. So they've. This is like a one pass, second pass. They're going to probably do a third pass. What's your prediction?
Yep.
What do you think? How many passes do you think they're going to go through?
I'm thinking it'll probably be about the same as last time. So we'll see. But last time they seemed pretty happy with 2 passes. So and it's turning like it did last time too, kind of the opposite direction than we expected.
Yeah.
But I don't think that really matters as long as it's not taking the same path.
Now, when you say it has to proceed through the obstacle course, now you would think that it would have turned right and then proceed down more, completing more of the obstacle course. But from a judging standpoint, they can keep sort of like circling.
That's an excellent question, and I'll leave that up to the other judges. But to me, I would think the biggest thing is it taking a little bit of a different path every time. So like when it went down last time, it was further to the left, and this time now it's going down, it's further to the right. So and when it came back on a different path than it's going down on right now. So to me, if it keeps going down and back on different paths, that's pretty much the point.
Okay.
It's showing that it can adapt to all the different obstacles.
This team would like to just to see where it goes when it goes past time, but stop judging at the time call. Or are you not okay with that?
No.
Okay.
Their run's done, they're done.
Okay.
They just wanted to see if it would go.
Yeah, they just wanted to see if it goes.
They just wanted to see if it would start that behavior. There's still a 10-minute window for the next quote.
So we're still in the obstacle course. We're still mowing the lawn.
Yep.
Mowing the lawn through the obstacle course.
Now, last time when it got back here at this point, I think that's when it started heading over to the totems. So
now
we'll
it
see.
still has to get to the opposite corner, right? So it exits the obstacle course through the opposite corner.
Well, since it's doing the lawnmower, that's not really true because it went down and back, and now it's gone down and now back, and so that's 2 full passes through as a lawnmower. So if they wanted to, they could head to the.
They can actually head to the next
over
axis.
to the totem. So,
okay.
So you can see they just sped up.
Oh,
and it looks like they're cutting on over. So I think they are headed to the totems.
Okay, so now they're headed to the totem, and based on the light tower, they kind of know what they need to do, right?
So looking at the light tower, at least with my eyes, I can see the red, green, red this time. So you can
red,
see,
green, red, okay.
So you can see it changes every time.
Right.
Last time they got to this, it was blue, green, blue. So now they're looking for the red buoy first, but they might find the other ones.
So
in the
red,
process.
green, red. That means, so how would the vessel now interpret this? What is the task that it needs to do around the totems?
So kind of like when it looked at the light tower, it's now looking at those totem buoys, and it's looking to see is there a red one, and if it finds a red one, then it'll go around it. And
Okay.
and then it's looking for the green one.
Stop judging. We're going to allow them to finish what they're running.
So.
Come in 3 minutes.
Okay, so the actual time has expired, and they are they back in manual mode and coming back?
It doesn't look like they are yet, although it's hard to tell. I can't see it, but they're letting them let it run a little bit autonomously, just a little bit longer, just in case it's just because they want to see what it would do when it finally finished the totems, quote unquote.
No, it didn't actually finish the totems, right?
No, it didn't. It looks
so
like it's
it
headed
must
back.
have sort of aborted that part of the exercise and now moving on to the next.
Indeed. So it looks like they're done. So something I would like to point out is they've got that little thing hanging down between the 2 pylons.
Yeah.
So that's their little underwater vehicle named Thunder 4.
Okay.
And so they put that on there to try to do the underwater challenge. Oh, so it is still autonomous right now, and it did come over here to look for the detect and deliver. So they're going to see if it found it, it's going to see it. They're not getting any points for this. They're just seeing if it would work, because that's their real goal.
Yeah, so the exercise that would take place right after the totem would be the detect and deliver.
Right.
And that's kind of a cool one because it actually shoots a projectile from the vessel into one of those square holes, right?
Yes.
So is it the big square or the little square?
Whichever one they can hit.
Okay.
All right, and they just went manual, so now they're completely
okay.
done.
They're in manual. So that's it for the Queensland team.
Yep.
And they did a great job all the way to the totems, and I guess we'll get one of the students over here and tell us a little bit about what the challenges were. But Martin, I want to thank you for
certainly
being our play-by-play.
Oh, I'm happy to
Great job, and I'm hoping to see you next time when you're out here judging.
Well,
so did you do this?
Did
you judge in 2016?
I did get to participate in 2016, and it was quite educational among many things. So I was pretty happy to be able to take the opportunity and come back again and see what these students are up to and how they're going.
Great.
Okay,
well, we're gonna try to corral one of the Queensland team members over here, but. Martin, don't run away yet.
Okay.
It's good to have you join me and telling me a little bit about the inside scoop of all these. So, of the teams, do you know how many of them actually have underwater autonomous little vessels that are?
That's a good question. I think I only saw about 3 or 4.
Okay.
But anyways, here's Leo. I'll go ahead and introduce him. He's their team lead.
Well, thanks, Martin.
Yeah, thank you. It was very fun chatting with you guys.
Well, now we got Leo, who's part of the Queensland team. He's going to join me and tell me a little bit about some of the challenges that they face. Again, my name's Bert.
Cool.
Congratulations.
Oh, cheers.
So you were here in 2016?
Yeah.
Great. So now you folks did the entry really well. You did the scan the code really well. You did the obstacle course. Now tell me a little bit of the obstacle course. I mean, you did first was like a diagonal, right?
Yeah. So the first shot, because we weren't too sure about how it was going to go. We really had little testing yesterday because of hardware issues. So the first time we just wanted to do a simple run. And then the next rounds we just went for the
So then you did kind of a lawnmower.
Yeah, that's it.
And
we
each
did 4
lawnmower
passes.
run was different, right?
Yeah. So we basically just make it go on different lines along the obstacle field and avoiding obstacles on the way.
Mm-hmm. And then you guys headed over to the totems.
Yep.
Right now, and you made it to the totems like twice.
Yeah.
But what was the challenge once you got to the totems?
So the first time, the algorithm that predicts the color of the totem failed when we got there. So we had to abort the run and start it again.
Wait, okay. So the algorithm that determines the color, how different is that algorithm versus the one that does the scan the code?
It actually is based on the same thing, just different parameters. But the architecture is the same.
And then, so do you have a sense as to why it might have failed?
Oh no, the actual program failed. So the program stopped as we were there.
The whole program stopped.
Just the part of the program that does the prediction of the color.
I see. Okay.
So we had to start again to restart the program.
Do you recall when in 2016 how far you guys got?
So we got second in 2016, but we did a lot less.
Oh yeah.
Yeah, I think all the teams this year did a lot. Hey Angie. All the team did a lot better this year. Last year I think we did the entry, the scan the code, and we went docking somewhere. And we went through the obstacle field, but really, really briefly, and that was about it. So we're a lot happier what we did this year.
No, you guys get it. So tell me a little bit about the team. Who is on this team?
So we are 6 or 7 people, including Matt. So Matt is our faculty advisor. And then, so I'm Leo. I'm doing most of the path planning and the obstacle detection and perception.
And what's your background? Are you?
I'm a PhD student.
And then, are you in computer science or what? What's your specialty?
So I'm doing robotics and mostly field robotics, so perception using lidars. So that's very much my field.
Great.
Yeah. And so
So do you have undergrads on your team?
Yeah. So Cal is an undergrad. We had a person from creative industry undergrad doing our website and all that stuff. And yep. Otherwise, I think the other ones are PhD students. So, yeah, Terrence and Emily are PhD students. They just started, but they're PhD students.
Well, very good, very good. Leo, I want to thank you for joining us and giving us a little background on the team. And good
my
luck.
Pleasure. It was very
watching.
cool to see.
We got our eyes on you. We're checking you guys out.
Cool. All right. I'm keen to see the next team.
Yes. So the next team is going to be the National University of Singapore. So we're going to take a short little break here because they're getting kind of set up, and I think we just got a couple of minutes before they actually start their portion of the run. So Leo, thanks a lot.
No worries.
Appreciate it. Thank you.
See ya.
Just that.
Okay, sure. I don't need to touch it.
No more.
Yeah.
Alright, everyone in the area, we're turning the mics on.
All right, we're getting ready for the next team. The next team is from the National University of Singapore. And now, are they... Okay, wait. First off, I want to introduce Josh. He's the embedded judge that has worked with this, kind of stayed with this team, right, for the whole week or so?
Yes, actually we started from Monday onwards. Yeah.
And Josh, where are you from?
I'm from the DSO National Laboratories in Singapore. So we are the defense R&D arm of Singapore.
Oh, okay.
Yep.
And so Josh, I mean, you are pretty familiar with this team since you're also from Singapore.
Yes, I've actually seen them done their operations in the jetty before, and they are quite impressive there.
So, okay, so you are in the industry. You're a judge. You're embedded. Now, can you tell me a little bit about this particular team? I mean, from the university, what do you know about who they are and what departments are they from?
Okay, so to the best of my ability, the NUS Bumblebee team was founded 7 years ago. They mainly competed in AUV competitions, which is autonomous underwater robot competitions. So they have actually participated in RoboSub, and they have actually been doing quite well. This year they got second, but they usually have been garnering top prizes. So you can see that their vehicle, there's the Bumblebee AUV, is their 3.5 version. So this year they actually brought it in with their ASV, which is the surface vessel, and they have successfully integrated it for 2018 competition.
Now, I like the name Bumblebee. I mean, they all got yellow shirts on, so they're very distinctive.
Yes, and it's a very easy to remember name.
Yeah. Okay, so tell me, what's happening right now?
So, from what I understand, they seem to be calibrating their position, and once they are given a start position, they will attempt to find the correct gate with the beacon.
Okay.
Yes.
So when you say they're calibrating, I mean, so the vessel has to get a sense as to positioning of the buoys and the distance that it is from the buoys?
Something like that. So for this particular course, it's quite special because there are currents here. So the beacons do drift over time. So the setting might work today, but it might not work another day. So they are just making sure that the positions are correct for the current competition.
Now this calibration exercise going on right now, I mean, this is still in autonomous mode, right? I mean, it's...
Yes, I think this is...
So the indicator that is that green light that's on top, is that the indicator for autonomous?
Yes. So actually this vehicle has multiple levels of autonomy, so they can still override it in the green light, but it's just a safety mechanism. Yeah.
Okay, so now it looks like it's... What, is it still determining... Is it still calibrating right now?
Yes, so it hits the buoy, so I think they're going to overwrite it. So based on what I understand, it seems that they probably drifted into the buoy. And
okay, so now they're back in manual mode, because I can see the...
Orange.
Yeah, it's in orange, yeah. Now, I did watch the Singapore video, and I thought the video was excellent. They did a really good job.
Well, Bumblebee is quite professional in my opinion. They have a big team. They sent about 17 of their members here this time.
17?
Yes,
wow.
That's a lot of people. And from how I see it, they handle the logistic and administrative aspect quite well. They always get food to eat and really good ones. Yeah.
Just tell me. I mean, did the Singaporean team, did they bring food from Singapore? I mean, are they?
No, so they source the food locally.
Oh, okay. Because I like Singaporean food, but I don't know how many places you can find that over here in Hawaii.
Yeah, but here their own specialties here as well are quite nice.
Oh, good. Okay, good. Okay, so now it's in autonomous mode right now, and are they still doing the calibration piece?
Yes, so they are still calibrating the starting position, and once the starting position has been determined, they will request for permission to start the qualification, and they will go autonomous. Okay, they have just got permission to go autonomous.
Okay.
Everybody knows I got Embry-Riddle still having MIA. Embry-Riddle. They're not here yet. Embry-Riddle. Do they have to be here? Who's their judge? Do they have to be there? Not yet. They don't have to be here yet. Not till about Florida has started running is when they should be here. But please realize this table is...
Okay, so now they're autonomous. They're going through that entry gate. Right, the red and white. Now they're heading over to the light tower.
Yep. So they will stop over around there. Then next they will have to locate the light tower, and to actually see what the correct code sequence is. And this code sequence actually determine a lot of things in the course.
Okay, so what's the light sequence? It's green, red, green? Green, red,
green, yes.
Okay.
Yeah. So there will be another judge that will be stationed near them, and they are supposed to report the color using a user interface back to the judge.
So now the determination of this is actually going through the scan the code, right?
Yes.
And the vessel now is actually looking at the light tower.
Yes.
So did they complete that task yet? I'm waiting for the applause. I haven't heard the applause yet.
Yeah. So it takes a while for the system to be sure on the correct sequence. So sometimes it may falsely detect one or two colors. So it goes through a few cycles to ensure that it gets the correct sequence out.
So the algorithm that's taking place right now, I mean, what is it? You said it has to do it a number of times. What is it correcting as it does multiple reads of that light tower?
Okay, so they are using a color filter. So basically, they are just checking out how many percentage of like red, green, and blue there is, and based on those percentages, what is the possible color that the lights are showing. And due to the lighting conditions, you sometimes can get a different assessment. So you run it multiple times, and by running multiple times, if your classifier is good, you can actually get quite good results.
Okay, so it actually completed that task, and it's moving on to the next one, which is, well, looks like it's heading to the
dock. I think it's heading to the dock.
The dock, okay, that's a new exercise that we haven't encountered yet. Now, as far as autonomous mode, there's basically the 5 tasks that each team is going to do, and they can do it in whatever order that they want to. Is that correct?
Yes. So the teams have to decide on themselves which task they want to attempt first, and usually they'll take those that has higher score and higher probability of success. There are some teams that actually have their own planner which actually decides for them which is the better task.
Okay, so now the docking exercise, they just have to enter that side of the dock, or how did they determine which side they needed to go to?
I'm not sure which side they have to go in, but depending on the colors they see on the dock face, so we cannot see them from this side. It determines the amount of time they have to actually stay inside there and station keep.
Okay. So now it looks like it's entered into the dock, and how do we know that the task has been completed? It's the amount of time that they actually have to stay.
Okay, so the judges here will be looking out for the point of time where the USB actually crosses a certain threshold and stops, and when it makes an obvious maneuver to reverse out of the dock. And we have multiple judges actually doing the timing here, and then after, when it comes out, the judges will compare the time, and they will see what is the correct time by averaging it. Yeah.
Okay, so now it's still in the dock. Is it just completing the designated time that it has to stay in the dock?
Yes. So I think the cruciform is the longest. It's about 25 seconds.
Okay. So now it's obviously spent the right amount of time. It's backing out of the dock and heading on to the next exercise. Now, can we assume that the docking exercise was successfully completed?
It will depend on the multiple judges here. So we have multiple observations, and then after each run, we will congregate to actually decide on the observations that we have seen here. So at this point of time, it will be hard to determine whether they have successfully completed it. However, from what I see, it looks like a success.
So when you say the multiple judges, how many judges are actually overseeing these exercises right now and contributing to the actual final score?
if I recall correctly, it's 3 judges per task, and you have a main judge that is residing overall that controls all of them. So I think at least 16. I think, yeah.
How many?
16. At
16.
Least,
okay,
at
okay.
Least, yeah.
So it's not all up to one judge.
Yes.
It's the cumulative scoring of 16 judges.
Yes.
Wow. Okay. Great. Now it entered the dock. It left the dock. Now it's still in autonomous mode. So it's thinking about.
Oh, so actually, if you notice the vehicle, the autonomous underwater vehicle has already been deployed.
Oh, okay. So now this is a new exercise. The autonomous underwater vehicle is being tasked to do what?
So they are supposed to actually find rings, which is located under the orange and blue buoy. And if you are near enough, you'll be able to spot the rings and to collect them. So depending on the number of rings they collect, they'll get a different amount of scores.
So which buoys are we looking at? When you say orange.
So
I see. Okay, there's
yes.
I see. So there's an underwater little smaller autonomous vehicle, right? That gets released, right?
Yes.
And then it goes and retrieves a ring.
Yes.
And now it has to return back to the vessel.
Yes. So there's actually scores for launching the small vehicles, collecting rings, and based on the number of rings, you get different number of scores, and they are of different depth. So the deeper, the harder is it. And if you successfully retrieve your vehicles, after that you get a certain set of score as well.
Okay, so right now this part of the exercise is actually all underwater. So from your determination, now it looks like they're moving on. The team has completed that exercise to retrieve however many rings they could.
Yes.
Okay.
So if I'm not wrong, they are going on to find the totems, and that involves actually circling around the correct totems in sequence based on the code that we see at the start.
Okay, so we talked a little bit about this before, and the totem task was kind of determined by the light tower, right? So the sequence of colors on the light tower determine what they need to do in the totem exercise.
Yes. So let's say if the color currently is green, red, green, they have to circle green, then red, then green. And depending on the colors, they have to circle counter or anti, either clockwise or anti-clockwise. Yeah.
So it looks like they've determined the location of the totems, right? So now they have to circle the.
So they are sweeping to find the totems, and then they will execute the turning maneuvers after.
Now these totems, they're actually a little like an image on the buoy, right? So there's 3 buoys out there that are colored. There's a green one, a blue one, and a red one, right? And there's a little image of a totem on it.
Yes, so they are just they are like buoy. They are like cylindrical shape. So they are supposed to be able to differentiate it from the other obstacles on the field.
Okay, so now, did it go around one of the totems?
It's a bit hard to determine from here, but I think it's still finding for the 3 totems.
Now, did the Singapore team name their vessel, or is it everybody's just a bumblebee? They're all bumblebees.
They are all bumblebees.
Okay.
Just whether it's a bumblebee autonomous underwater vehicle, or autonomous surface vehicle, and they just give it numbers behind, like Mark 1, Mark 2, Mark 3. So this is autonomous surface vehicle version 2.0, and the underwater vehicle is at 3.5.
3.5.
Yes.
Why? So there were variations of it before.
Yes. So they had actually 3 more versions at least before this.
Okay. So now it looks like what's happening now? Is it coming back, or are we in manual mode, or is it going to another exercise?
Well, at this distance, it's a bit hard to determine the colors.
Yeah.
Okay. So they are coming back in RC mode.
Well, that's pretty impressive. Nevertheless, I mean, they completed a lot of exercises.
Yes.
And it looks like they're coming back.
So I guess that they are restarting again.
So we're observing the National University of Singapore. We're talking to Joshua. He's my co-host here, and he's the embedded judge for this team. This team called Bumblebee, they've actually done quite a good job of completing a number of the tasks. I mean, they did the scan the code, they did the docking, they did the retrieve the ring,
yes,
and they went to the totem.
Totems.
And now, but they are coming back, and they actually want to restart. Now, let's say hypothetically, this next round they do less than the previous round. Is the scoring based on the best sequence of tasks that were completed?
Yes, so the scoring will be based on best run.
Mm-hmm. Okay. So they might do better, they might not do as many, but it's all about the best run. So they all have 30 minutes, right, to complete as much of the course as they can, and they can repeat the autonomous mode, right, from the beginning if they want to.
Yes, so this actually incentivizes them to actually try and achieve better results instead of retreating after they have achieved what they felt is their best. So this actually pushes and challenges the team even further. So each time they get a good run, they have to think that, oh, we can do even better, and they will push for another run.
Now it seems like the that totem exercise is challenging because the team previously from Queensland also seemed to have some challenges with the totem.
Yes, so it depends on how you detect the totems. So the totems, you need to use multiple ways to actually detect the totems. So some teams will use the LiDAR, but using the LiDAR means that they can't see what color the totem is, and hence they have to correspond it with their cameras. So it's a two-layer approach to actually solve the problem. And if either one of them fail, you can get bad results. There are some teams that actually try to use just the camera to just detect and work with that. However, it poses some difficulty as well.
So it's not just one set of sensors that's going to help you do your task. It's a multitude of sensors.
Yes.
That all need to be combined and then analyzed, and that becomes the basically the information that you can determine how to proceed.
Yes. So of course the easiest would be to use the LiDAR because it directly gives you like the distance you are from the object.
Right.
So it's pretty easy to make an assessment based on whether you can clear this area or not. However, of course, when you are dealing with things like totem beacons buoys, the difficulty is actually increased because now you need to recognize that these are of a certain objects, and you need to actually act in a specific way when you see these objects.
So we're watching the National University of Singapore. They are getting ready to start this. Basically, it's their second run or third round.
So I think they had some difficulties starting.
In the first one, right? And then the second one was pretty. They went pretty far.
Yeah.
And they went all the way to the totem, and now they went back into manual mode, and now they're doing the sort of this calibration.
The calibration, right? And the scan. So you realize that this USB is able to slide in multiple directions. So it has what we call holonomic. It can do things that a standard boat cannot. It can like turn on the spot, slide around, and so they are actually basically making use of these maneuvers to help them clear the task easier than a standard boat does it.
Okay, so now they've actually gotten into the course, or are they?
Yeah, so it seems they are restarting again.
Okay, so they're back in manual mode. So they're gonna come back and reset, probably do some calibration again, and then re-enter the course in autonomous mode.
Yes. So we shall see if this run is more successful than the second run. Hopefully it takes them even further.
What's the worst thing that could happen? I'm in Hawaii right now.
What's that Janelle doing out there? She's taking a picture that has the boat and the plane in the same frame. Wow, look at that. Nice.
Well, it's Hawaii, right? You gotta have some fun.
We're live casting from Hawaii. We're off of Sand Island. This is like the perfect place to have a competition. Of course, there's not a whole lot of wave action here because it's protected by the reef. And we're watching, live casting the RoboNation Maritime RobotX Challenge for 2018. And we are well underway. We've already seen the National Chiao Tung University from Taiwan, and then the Queensland University, and now we're watching the National University of Singapore. And they are kind of probably use most of their time. I think they're probably running into close to their time limit, but I'm not sure exactly what. I know they all have 30 minutes to complete their attempt at these finals. So they're getting started again. They've already done a pretty successful run in my mind, but they're gonna go into autonomous. They're actually in autonomous mode right now. They're doing their calibration, and they're gonna go through the predetermined gate. Now they shouldn't be hitting any of the buoys, right?
Yes.
Okay.
So I think they are going to start on scan the code.
So now the scan the code. Okay, so the code has changed.
Yes, so it's randomly generated every time. So when the course starts, the gate beacon actually changes, and the light sequence also change. It means that the task that they have to clear is actually changed. So when they exit, I think the beacon would also change.
Now that's an important piece because right now it looks like it's the light tower is showing green, red, blue. So green, red, blue is the sequence of colors, and that was different from the run that they had done just previously. So that will inform what they need to do, especially with the totem.
Yes.
Right?
So one is the totem, so it determines which totem they have to circle around, and the second is how are they going to pass this light tower. So if I recall correctly, green is you pass on the starboard side, red is you. So on the first color of the sequence, it will tell you how are you supposed to pass this light tower. So green, if I'm not wrong, you pass on the starboard side, red is the port, and blue you have to circle around it. So some teams might find the blue a bit more challenging because now you have to do an extra maneuver around it.
So it looks like they've done the scan the code.
So if the sequence was the same as just now, they will be heading to the dock next.
Right, so the sequence that they previously did was do the scan the code, and then went over to the dock and actually docked. But each autonomous series can be different, right? They could have chose to maybe do the obstacle course or do something else.
Well, for this team, they actually choose the course manually. So it's human, is determined by a human.
Right.
But some teams actually do have a specific planner that decides which is the order they will attempt it.
it's almost like the team has chosen the most difficult things to do in the beginning, and then move on to some of the easier ones.
Well, so looking at the NUS track record, is that they actually cleared the dock the earliest among all of the courses. So to them, it's actually one of their easier tasks.
Oh, I see.
So for the light buoy, they do not have a choice, but upon entry, they have to actually look at the sequence and determine how to pass the light. So that has to be first. So next will be their favorite, which is docking. Yeah.
Now, in the first run, they stayed in the dock maybe 30 seconds or something.
Yeah.
That's determined by some code on the other side, which we can't see. But how would the vessel know how long they need to stay in the dock?
So when they are actually moving into the dock, your cameras will already be pointed at the sequence, the shape that is in the dock, and based on what they see there, they have to detect and to decide how long they have to stay in the dock for.
Okay, so then the last time they stayed maybe about the 30 something seconds, we would probably expect them to do something similar?
Well, if they detected the same shape, they should stay at the same time.
Okay.
So you can see this is not an easy challenge. They go in and the dog is actually swaying a lot. So it adds an additional level of difficulty to this particular exercise.
Now, are all the exercises the same amount of points, or are there, like the maximum that you could get are all the same, or is it a different weighting?
They actually have different weightings. So if I recall correctly, the two tasks with the most points or the maximum points are the obstacle field and the underwater task. So most teams, but they're also the most challenging. So teams that could actually clear this will actually be awarded the most number of points. The other tasks do have points, just that lesser, but not that much lesser.
So again, which were the most difficult? I know the ring, retrieve the ring is very difficult, but what else would you consider the difficult tasks?
So it really depends on the layout of the platform, and it's actually really an engineering design. It's a trade-off. Certain teams, they actually have certain configuration which is easier to clear certain tasks. Other teams, they might find another task easier, but another task easier. So it really depends on the trade-off that the mechanical team actually decides.
But from a judging standpoint, I mean, as you guys have kind of put this course together, what would you consider more of the difficult task?
Okay, definitely the underwater ring recovery. You have to do underwater detection, which is not an easy feat.
Yeah.
And you have to control autonomously another sub. And of course, it also poses a mechanical challenge because the sub launch and recovery mechanism is actually not an easy task to do. So you actually need a lot of engineering effort to actually incorporate it into the design of your surface vessel.
So when you say recover, when it's underwater, is the surface vehicle recovering that underwater vehicle, or is the underwater vehicle actually, docking or connecting to the surface vehicle on its own?
It really depends on the design. So some of the designs requires the underwater vessel to actually move into a certain position to allow the surface vessel to lift it. Bumblebee's way is to actually use a winch and a cable to actually hold onto the surface vessel.
Oh, I see.
So all they have to do is just drop the sub into the water and you can operate autonomously.
So there is a line that still is connected to that underwater vehicle, and then it just goes out and they can retrieve it back.
And after that, using the same line, they will pull up the underwater vessel and they will actually dock it under their surface vessel.
So did they? Looks like they're coming back to shore. So did their time?
Yes, their time ran out.
Okay. So that's it for the National University of Singapore. They did a really great run, and they were attempting to do a third run, but I think time ran out, so they are taking their boat back, and we will get prepared for the next team to attempt this course. But in the meantime, we'll get a student over here from the Singapore team and talk story with them.
Okay.
All right, great.
Yeah.
Well, thanks, Josh. Thanks for Josh for joining me.
Thank you.
All right, so now we have one of the team members from the Singapore team. You're like what, the chiefess bumblebee? Are you like the queen bumblebee?
No, I'm actually the software lead of Team Bumblebee.
Oh, okay. Yeah. So we're talking to Ruth, and she's part of the Bumblebee team. Tell me, Ruth, what are you studying in school? I mean, what year are you?
Oh, so I'm an undergraduate year 4 from NUS studying computer engineering. And our team are made out of mainly undergraduate students studying mechanical engineering, electrical engineering, and computer engineering.
So this team, I gotta compliment you. You guys did a great job with the video. You did a great run. Went all the way to the totem. What was the challenge, I guess, with the totem?
I guess the totem was the camera, because the sun is really shining, and it was kind of hard to detect. Yeah.
So, and what was the task that you needed to accomplish at the totem?
So we have to circle around the totems according to the light buoy sequence. Yeah, and the direction would be determined by the color of the totem.
Now, I'm impressed because the previous teams, they went and did the scan the code, and they went to do the obstacle, and then they went to the totem. But you folks went right into the docking, and docking was pretty straightforward, right? You dock, and there's an amount of time that you have to stay in the dock. But then right after the docking, you did retrieve the ring, right? Tell me how did that go? Because we couldn't see underwater. So from a team standpoint, how many rings did you folks retrieve?
No, we didn't retrieve any ring. The focus was actually on the launch and recovery system, where we launched the AUV and recover it safely. Yeah. So as far as the judges, I mean, they would look at the attempt to go after the rings, but just the fact that you were able to launch the underwater vehicle and retrieve it is part of that exercise as well. Yes.
Oh, good. So, did you feel that that was a success?
Yes. For the overall run, it was pretty good. We did most of the things that we were aiming to, especially the launch and recovery system and the docking. So it was quite a solid run.
Oh, good. And then right after that, you attempted the totem, right?
Yes. So the totem is actually one of the tasks that we are not as confident with. That's why we went for it after the totem, the docking and the last.
Now, some of the teams, did the obstacle course. Was the obstacle course considered like easy, and we could do that later on, or just from a point standpoint, you could have done that, run through it, and then go to the dock and dock? I mean, what was the thought process on choosing what sequence you would go to?
So for us, we went by our most confident task, and we aren't that confident with obstacle avoidance, so we left it to the end.
Oh, I see.
Yeah,
Okay.
We are, I guess, most confident with docking as well as the launch and recovery system, so we went for it first.
And you said that the confidence level for the obstacle course wasn't as high. I mean, what was the challenge? What was the challenge there that made you not so confident?
So the challenge was detecting the small buoys, because we only have a 16 plane LiDAR and it's mounted quite high up, so we can't detect the small buoys in quite a lot of scenarios when we were testing over this week. So we decided to leave it to the end.
Now, you said that the team is mostly undergrad. Or
yes.
Are there any graduate students, or how do you do any succession, or how do you sustain the level of continuity from 2016, 2018, and going into 2020?
So our team is mainly undergraduate, and there's no graduate student, but there's a research engineer. So how we run our team is we recruit year ones undergrad students and make them build their own autonomous underwater vehicle. And year 2 onwards, they will focus on the main vehicle. And we try to have a mix of different years, students who are at different years to come to the competition itself. So we have quite a few year 2s, and they'll be around for the next RobotX as well.
So are you going to be around for 2020?
No, I'm graduating soon.
Oh, yeah, okay.
Okay, come back as a judge.
Oh, you'll come back as a judge? Okay.
Maybe.
Okay. So you said you had about, what, 17 students out here?
Yes, we have 17 students here.
So how do you like Hawaii?
It's very sunny.
Singapore is pretty sunny, right?
Yeah. So I guess they are quite similar in that sense.
I see. Well, great. So Ruth, I mean, I'm really happy to have you join me and talk a little bit about the Singapore team, and congratulations on a great run.
Thank you.
Good job.
Thank you.
Oh, thanks. I got a sticker. Okay, great job. Bumblebee, Team Bumblebee.
Yes.
Yep.
All right, so we're getting ready for the 4th team in the final round of the Maritime RobotX competition, the 2018, thanks to RoboNation. And now this is the team that we need to watch. You guys were the champions, right, in 2016?
Yeah, we were the champions in 2016.
Yeah, I've been watching your video. I got my eye on you, Now, I have, joining me is Matt. He's actually part of the team. So Matt, tell me a little bit about what you do. Are you you're a PhD student or what are you?
I'm a master's student in electrical engineering at the University of Florida. I'm the team leader, and I also run the electrical team.
Okay, great. So were you involved with the team in 2016?
I was. I've been with the team since we started in the fall of 2015.
And how did you elevate to the team lead role?
Well, I've been in our lab quite a while, about 5.5 years now, and so when the last team leader stepped down so he could focus on his PhD and graduate at the end of 2016, I was the natural choice to be the team lead.
Okay, great. So tell me what's happening right now with the University of Florida.
So
boat here in the water.
Right now we're at the start gates. Between each start gate is an underwater beacon, and our goal is to find the gate with the beacon that's turned on. So we go to 2 different points on the left and right of the start gate, and we listen for the beacon. And we're able to get the bearing to the beacon, and then we find the intersection of those points, and that tells us which gate to go through.
So right now we're already in autonomous mode. It's kind of just going through or determining which one has the beacon, and the beacon will inform the vessel which gate to go through.
Correct. So it's currently listening at the second point for the beacon. Notice that it's kind of drifting in the wind. That's because we can't listen too well with our thrusters on.
Oh,
so now
okay.
It has decided where the beacon is, and it's going to line up and go there. It looks like it's decided the beacon was in the middle gate, and now it's approaching scan the code to look at the pattern.
Okay, so now from our vantage point, the scan the code, it looks like it's green, red, green.
Yes, it does look like that. Hopefully Navigator thinks so too.
Okay. So what's going on with the boat? How is it determining that?
So we use our LiDAR, which is a depth perception sensor, to detect where the scan the code is. It has a kind of a distinct shape with its base and then a column in the middle, and we use that we kind of look for that shape in our LiDAR information. Now what it's doing is it has found scan the code. It's standing off so you can see it with the camera that's on the starboard side.
Okay, and so this is not it hasn't.
Excuse me. It looks like we've going somewhere else. But
so have you completed the scan the code exercise?
I'm not sure. We may have done it quickly.
I haven't heard the applause yet, so I'm kind of wondering
yes.
Are they so? Based on what we're looking at, do you think that it's sort of moving on to the next exercise?
It would appear so, yes.
Okay. Now, as a team member, do you know what the sequence of exercises you're undertaking?
Yeah, so the general sequence we're undertaking is kind of a clockwise rotation throughout the course, starting with the start gate, then scan the code, then I believe we're supposed to go to the obstacle course next, then circling the totems, ending with the detect, deliver, and the underwater ring challenge.
All right, okay. I hope you make it to the detect and deliver, because I'm all excited about that, and I want to see the projectile go through the square. But okay, so right now you said you was going to go to the obstacle course, right? But it looks like it's sort of.
It looks like Navigator got a little confused and needs to abort, come back.
Okay, so I heard that. I heard the abort. So that means that it's gone in manual mode, and it'll come back to the beginning and start again.
Yeah. Well, while it transits back, I want to mention some people have really helped us out. We're really thankful to our departments, our EC department and our MAE department, as well as our industry.
Okay, what did you say? MAE?
Sorry, mechanical and aerospace engineering.
Okay.
And electrical and
feel
computer
free to
engineering.
call out to all the departments and don't just do the acronym, because nobody knows what the acronyms are.
And our former team lead, Andy Gray, he's helped us out a lot. And our industry partner is a company called Silphase. It's a startup from our former student focusing on sensors for autonomous robots. And then our lab, of course, is the Machine Intelligence Lab, or MIL. And some of our faculty advisors come from another lab called CIMAR, the Center for Intelligent Machines and Robotics at the University of Florida.
And then that department. I mean, how long have they been around? MIL? CIMAR.
CIMAR's been around quite a while. They participate in all the DARPA Grand Challenges, but our lab, MIL, we've been around for over 20 years. We participated in every single Robo Sub competition, many of the Robo Boat competitions. This is our second RobotX competition, and we have a number of championships to our name.
Now tell me, what is it about the Florida and where you were at that has a lot of this activity going on? I mean, is there a big presence with in terms of the Navy or what is it that's driving a lot of this activity?
Yeah, so a lot of our activity is driven by our lab, Machine Intelligence Lab. It's been around for a very long time, over 30 years, and it's always been a place for people to come and kind of do the research they want to do with robots and work in an environment where everyone feels the same. So our lab is largely undergrad, and everyone in our lab is a volunteer. No one's paid to be in our lab. and they just really enjoy building robots and going to competitions like this.
So this machine intelligence lab, is it all kinds of robots? Is it terrestrial? Is it like unmanned aerial? Is it underwater? I mean, what specialty would you consider the machine intelligence lab?
Over the years, this mill specialty has transitioned from stationary robots to ground vehicles, to ground and air vehicles. Our current focus is on water and underwater robotics.
Oh, okay.
So all marine robots.
Yeah. So tell me more. Did you get to thank everybody?
I did. I thanked everyone on my list. I should probably mention that our electrical and computer engineering department is run by Dr. Han, and our mechanical engineering, Dr. Harris, and our mechanical and aerospace engineering department is run by Dr. Han. And our big sponsors are Texas Instruments, Harris, Lockheed, Blue Origin, and Northrop Grumman.
Wow, that's some pretty big names.
Yes.
So those companies that you just mentioned, are they all located in Florida? Do they have a presence?
They're not. They're all global companies actually, but they do have groups in Florida, with the exclusion of TI. The TI recruits a lot from our school and really believes in our lab.
And then so those companies, in terms of sponsorship, in what way do they help sponsor?
The sponsors I mentioned sponsor us fiscally.
Okay.
Silphase helps us with our sensors. It looks like we've started the entrance gate again. We're repeating the same pattern we did before, listening at 2 different points.
Okay, so now it's back in autonomous mode. It came back and basically restarted, right?
Yes, it did. We had to abort our first 2 runs. Oh, we're aborting this run as well.
Okay. So now this is a little concerning, right? So it didn't even try to get through the entry gate. What do you think happened to decide an abort?
It looked like they had some information early on that made them realize this wasn't going to be a terribly successful run. It looks like we're looking for a quick turnaround to go back to autonomous. Eavesdropping on what my team's saying, but ultimately I know as much as you do right now.
Okay, which is not a lot, but I mean, like, they're right next to us.
It looks like we went autonomous again.
Okay. Now we got one.
I want to point out that our boat, we have 4 thrusters, 2 on the bow and 2 on the stern, and our thrusters aren't aligned with to front and back. They're actually angled at about 30 degrees. And the reason for that is it allows us to move in any direction we want and maintain a lot of control and maneuverability, which is a great help for a course like this where you need to maneuver around in between buoys and towers and obstacles like that.
Well, tell me more about some of the other systems that are on this vessel.
Sure. So outside of our thruster system, we actually have a pneumatic air system on board. And the pneumatic system powers our racquetball launcher, which we hope to use for detect deliver. It's an auto reloading system that uses 100 psi air to propel a racquetball through the squares on the detect deliver challenge. All of our electronics are housed in a car top carrier on top, and that's an effective and cost-effective way to protect your electronics while maintaining easy access to them. You just open the lid, and there's everything you need.
So that car top, that's the one that's silver that's sitting on top of the vessel, right?
Yes, we've covered it in reflective tape to help keep it cool.
Oh, I see. Okay, great. So now it's what? It's still in manual mode.
Correct. It looks like they're lining up for a new run. Now they're station keeping. We can tell it's station keeping because we've heard they haven't started the run yet, and the light is green, and it's not moving anywhere. Our station keeping code is very good. It's absolute station keeping. So we say stay here on planet Earth, and it will stay there.
So when you say station setting, right? Is that what you said?
It's station keeping.
Station keeping. What is it that's actually happening with the sort of like the navigation, the propellers,
Yeah, sure. So we have our primary position sensor on Navigator for absolute positioning is something called an INS, or inertial navigation system. It combines 4 different sensors: a GPS, something called an accelerometer, a magnetometer, and a gyroscope, and fuses all that data through some math called a common filter to establish the idea of where you are on Earth and which direction you are facing. The product we use to do that is designed by our Silphase, run by a former student in our lab. And then, based on that information, when it detects that we have shifted away from where we want to be, our controller plots the thrust trajectories we need to get back to where we are, given our current rotation and where we and if it's to the left or the right or forward of us, where we need to go to.
Okay, so it's in autonomous mode. It's doing sort of talking to the beacons. I mean, determining which gate to go through.
Yes, we're doing this again. Hopefully, we'll be progressing from this point to the other challenges on the course. Once again, like we listen at one location, we move to a second location and listen there. The idea behind this is when you listen, we have an array of 4 hydrophones, and what this does is just like the human ear, we have 2 ears on our head, and that allows you to tell if a sound is coming from the left of you, to the right of you, or behind you.
Okay,
looks
great.
like we went through the.
Whoop.
Not sure what's happening here. So just like you have 2 ears on your head, we have 4 ears on Navigator.
Okay.
That allow us to
listen to the beacons, right?
That tell you not only if it's to the left or the right of Navigator, but how deep it is.
Oh,
and with
okay.
this information, we can say from where we are currently, it is to the right. And then when we move to a second location farther away, we say, oh, it's to the left. And we know it's which gate is in between.
Okay,
it looks like what happened here is we figured out that the buoy was the beacon was in between the red tower buoy and the white tower buoy, but then we thought it was too narrow for us to go through, so we went around.
Now, is that a acceptable performance, or do you have to go through?
It looks like we are letting it happen for the moment. We want to get the points for going through there.
Well, in order for you to go through it, you have to go through the red and the white.
Correct.
Right?
It looks like we have aborted and gone back to RC mode.
Okay.
And
So yeah,
recovering our vehicle.
Now, can you have followed that path and then maybe backed up through the red and white?
Not for points.
Okay.
If we decide it's too narrow, we can't go through in any configuration, forward or back.
Now, when it determined that it was too narrow, I mean, you guys have done the qualifying rounds, right? So you've already gone through this. It's not like this is the first time. So what was it that changed this time to make it feel like it was too narrow?
So they reconfigured so for the first couple of days of competition, there were qualifying rounds, and they had courses laid out for that. Then they reconfigured the courses for the semifinals, and finally they reconfigured the courses for finals.
Oh, I see.
For finals, they try to make things harder on you.
Okay.
As they should.
Okay.
And so appears that they've tightened the tower buoys together.
Okay, so we don't expect a complaint letter from University of Florida to the judges, right?
No, we do not.
Okay. Okay, so now it's in autonomous mode. It's gonna continue the sort of initial sequence, right? Which is to listen to the beacons.
Yeah, we just got a word that we are autonomous and we'll be attempting this challenge again. So we're also told that the correct gate is the middle buoy, or the in between the white and white buoy in the center. So fingers crossed we'll go through that one. It looks like we're going now. So again, we'll listen at one point, listen at another point, and then go through.
Okay, so we know that the gate is 2, but the vessel has to now determine that on
Correct.
its own.
Yes, and the reason we're told that is that while we're running autonomously, our software team is not allowed to touch their computers or remote control.
Right.
So we can be given information and not be expected to influence the robot behavior. When we go through the start gate, we're going to stop at scan the code and try to recognize the light pattern, which appears to be red, green, or red, blue, red. Once based off that information, after we go through the obstacle course, we'll go to the circle totems, and we should circle the red totem, the blue totem, and then the red totem again.
Oh, okay. Now, I'm excited to see that because, the other previous teams went to the totem and were unable to complete that. So if you guys complete that, you'll be the first one today to do that.
We'd be happy with that.
Yeah.
We've done it a number of times during the semifinals runs the last couple of days. So
so
we're confident in our ability.
So some of the teams have told me like which they have considered to be like the more difficult tasks to complete. Which does the University of Florida deem the most difficult?
To us, the difficult tasks are the scan the code challenge and detect deliver challenge. We're pretty happy with our ability to do the obstacle course and circle totems. So we rank them that way.
Oh, so you would say scan the code was one of the more difficult?
For our team, yes.
Oh.
Yes.
Now, how much of the system has already been in place from 2016? Could you reuse that code or reuse the system? Or do you have to start from scratch? I mean, wasn't there some lessons already learned from the previous competition?
Yes. So we received our boat in the November of 2015.
Mm-hmm.
We were in the water a week later, and we got ready for the 2016 competition.
Mm-hmm.
Our strategy for getting ready in that short period of time, about 13 months, was to get something working and then go back later and improve it. So we had to get thrusters, electronics enclosures, sensors, write the controller and mission planning software, and then also complete the tasks. Of course, when we finished 2016, we didn't throw our boat away.
Mm-hmm,
So we started with a platform that had all the sensors and actuators and batteries and things that we needed, and then we were able to improve off of there. So from 2016 to 2018, our team strategy was to, based off the areas of improvement we noticed that in the 2016 competition, improve for the 2018 competition. So we did have a bit of a leg up in that we weren't starting from scratch again.
Now, recognizing that scan the code was a challenge, was there work being done in the period between 2016 and 2018 to improve or build your confidence for scan the code?
Yes, that's a challenge we worked on a little bit. Not enough.
No,
We're realizing we do work consistently. We work fall and spring semesters, excluding the summers, from the time competition ended to now.
Okay. Now, from what you just saw, did it complete the scan the code?
I'm not sure. It certainly drove by it.
Okay.
It
So
looks like right now we're going through the obstacle course.
Oh yeah. Okay. So we don't know. It's moving on. It's moving on to the obstacle course.
For the obstacle course, it's going to attempt to do a lawnmower pattern.
Okay.
So it'll cross the obstacle course and then turn around and come back. It should do that 3 times if everything runs correctly, and that will reward us with a fair number of points. The lawnmower pattern is considered the most difficult pattern to achieve. I want to talk about. I mentioned about we test quite frequently. Back home, we have our university has a lake. And we're able to test on the lake, so we go out there every other weekend, every weekend or so, and we take over a section of the lake for all day.
Okay.
We build replicas of every single course element, and our mechanical electrical teams deploy them, while the software team writes the software or tests the software for Navigator. It's a whole day affair. We make lunch and stuff like that. So it's what's interesting about these big robots compared to RoboBoat and RoboSub, if you've seen those, is how much logistics is involved in just testing the robot or even getting it to Hawaii.
Oh yeah. In fact, I was looking at just the team videos and all the work that you folks have done, at your home base, and imagining having to take that all apart and bringing it to Hawaii. I mean, that's incredible. So, how did you guys end up shipping this? Was it by air? And what's the challenge to disassemble it and bring it over here?
So the boat itself came here by air. We shipped a lot of tools. It came in a big crate. We ship a lot of tools and spare parts and things, and those come in Pelican cases also by air. When the boat returns, because we're not so concerned with how fast it gets back, it'll come by sea.
Oh, okay. So you do a surface delivery going back.
Correct. Yeah, sea and land.
Probably have to go through the Panama Canal.
Yes.
Is that the route?
Yes. Goes through the Panama Canal. We went through the Panama Canal in 2016. And now in 2018, I'm sure we'll go back through it.
Well, maybe you'll get it in sometime in 2019.
Yes, we're supposed to get it in the end of the first week of 2019.
Okay.
Which is good because before that, our university is closed.
Okay.
So no one will be there to get it.
Now, in terms of, just curious, in terms of time of year, is this a good time of year or a bad time of year to do this exercise? I mean, given the fact that a lot of people are having finals and they've got semesters ending. I mean, what did you guys have to do to actually deal with the coursework?
Yeah, I want to reiterate that our team is mostly undergrad. Of the 11 people that we brought, which are the ones that we were able to bring, 9 of them are undergrad and 2 are master's students. And of course, they have lots of finals, and so the competition falls during our finals week.
Right.
So the students individually can coordinate with their professors to either take exams early, or to take them in Hawaii. Many of the students had to take exams in Hawaii. In fact, one student had to take 4 exams here.
Oh.
Which is rough for him.
That doesn't make for a very good, Hawaii experience. Taking finals in Hawaii.
No, no, it does not. It looks like Navigator is transiting through the obstacle course. We went across, and now we've come back, and hopefully we'll go across again.
So the programming is it predetermined how many times it goes back and forth in terms of the lawnmower run?
It is. We pre-code what tasks we're going to do and in what order, and then we also pre-code what you do during each task.
Okay.
We have a quite a nifty GUI mission planner, which is a GUI is just a screen where you can use your mouse and stuff to drag things around. So you drag the task into the task list, and you can reorder it and whatnot, and then you press go, and it goes and runs everything.
Okay, so now it's just kind of turning around to do maybe another run through the obstacle course?
Yes, it looks like it's starting that third run through the obstacle course. It has to. It takes a minute to plan its route because of the obstacles that are in the way. But luckily, it sees them with the lidar. So if you notice, there's a lot of black buoys on the course.
Right.
And the way we see them is not with our camera; it's with our lidar. So a lidar is a depth perception sensor. So it sees this flat surface, and then it sees deformities in that surface, and we know that those deformities are obstacles that we can't go through, and we divide the world into squares, approximately a meter by a meter. And if we sense any deformities in that square, we mark that whole square as something we can't go through. And that's kind of like if you had a graph paper and you just colored in certain boxes and then try to draw a line through it, like a maze. And then we have a piece of software called a path planner that, given that maze, plans the best route to get from where you are to where you want to go.
So that LiDAR system, I mean, what does that include? I mean, and is that an expensive piece of equipment? I mean, what is it composed of?
LiDARs used to be an expensive piece of equipment, but they've gone down quite a bit recently in price in the last couple of years, especially with the rise of autonomous cars and just robotics in general.
Right.
It has 16 lasers that spin around in a 360-degree circle and measures the return of those lasers, much like a sonar would work, but a sonar uses sound while a LiDAR uses light. So
now the 16 lasers that you're talking about, I mean, can you sort of tell me where on the vessel it is?
Yeah, the LiDAR is a small puck. As the top and bottom are silver, while the middle is black. It's located on the front of the vehicle, so it has the best view of the course from the vehicle's perspective. The way it tells the 3D depth is based on how much time the laser light leaves the sensor, hits something, and bounces back. And based on how long that took, you know how far away the thing is. And based on the strength of the return, you know how reflective the surface is. So the buoys they're black, so black absorbs a lot of light, while the ocean is water, and that has a different light absorption rate.
Do you know what frequency that laser is? Is it infrared, or is it what?
It's certainly not visible. It's safe for human eyes. I don't know more beyond that.
Okay. So now it seems to have gone. I would have guessed that it would have gone to attempt to get toward that other side of the obstacle course, right? Which is from one end to the other end.
So with the lawnmower pattern, you just have to go back and forth.
Right.
And normally we would start at one side, go through, move a little bit, come back, move a little bit, go back again. But it looks like maybe it decided it couldn't fit on the right-hand side, so it decided to keep going through the left-hand side. Now we should be transiting to the circle totem challenge.
Okay, so it's already kind of finished the obstacle run. It's done its requirement, I guess, in terms of transiting back and forth. Now it's going to head over to the next exercise.
I believe so. We'll see what happens.
Okay, we'll see. I'm counting on it because I want to see you guys complete the totem exercise.
Thank you. While it transits and gets to the next, decides what to do, decide what it wants to do, and gets to the next challenge, I do want to give a shout out to our judges and our staff here. They've really done a very good job instituting a culture of safety from the top on down that they've really driven into us. And for an institution, that's the best way to enforce safety rules, is to really enforce them from the top on down. And I don't think we've had any safety incidents so far, and everyone knows that safety is the primary concern. There are plenty of safety checks before we go in the water, when we're on the water, as well as every team is required to have a very robust kill system. and its functionality is strictly enforced. So,
And that's a common message and theme across all the judges, right?
yes, they really got everyone on board with the safety with the safety culture, which is for the best. You want to be safe when doing anything, much less autonomous robotics on the open ocean.
Well, even sitting in this booth, I don't want this monitor to fall off.
Yeah, that would be pretty bad. It's just kind of hanging there.
Okay, so now it's at the totem, right?
Yes. So
and now it's gonna, based on the light tower, right? It already knows what sequence it has to follow.
Correct. Looks like we've just aborted our run.
You know, that totem exercise, man, it's like killing all the.
Yeah, it looks like it. I'm not sure why we aborted this time, but
no. Let's see. Okay, so just hypothetically, if it's like maybe kind of a challenge, can you resequence the exercises that you attempt?
Yes.
So instead of going to the totem, you know, maybe do a docking and maybe do the ring retrieve.
Yes, based off of how much time we have remaining, and how confident we are in our ability to complete tasks, the software team can use that tool I mentioned earlier to change what tasks we do and in what order.
Right. Okay. So right now, if it's in manual, it's got to come back. It's going to have to restart everything. So at a minimum, I mean, you know, you've already done the scan the code and the obstacle, but you're gonna have to redo that again, right?
Yes. With this competition, they take during your time period, they take your best run as the run that you get points for. In 2016, it was a little different. It was the run you ended on. So we had to do a lot of strategizing on, okay, how was that run? How does it compare to what our goal is it worth attempting to retry? Because if we don't achieve the same score as we did last time, then that's it. We get the new score.
Right. I mean, you know, like in the previous team, the Singapore team, they actually were able to go pretty far in one of their runs, and then they came back and they attempted, you know, to redo the course, but they were never able to get as far as they got, you know, in that one run. So I think that's probably going to be the one they measure.
Yes.
So what? You got a message here?
Yeah, I received some intelligence from my team that we are going to attempt the underwater ring challenge. We're the only team at this competition so far who has deployed and retrieved our AUV as well as retrieving a ring from the course.
Right. Because the Singapore team, I asked them about that, and they were actually looking at just launching and retrieving, but they did not get a ring.
Correct. It is worth noting that our AUV is attached to our vehicle, as opposed to a separate sub that we deploy. We have a what kind of looks like a tree. It's like a long stick with hooks on it, and it approaches the challenge, lowers the we call it the Grinch, because we think of the underwater ring challenge as kind of like a Christmas tree, and the Grinch goes and steals ornaments, and our intention is to steal rings.
Okay, so now it's in autonomous mode. It's gone through the entry, right? It's got to still. Does it have? It has to do the scan the code, right? Or no?
I'm sorry.
Does it have to do the scan the code?
We don't have to do scan the code.
Okay. So now it's just going. It entered. Now it's going to go do which exercise? The ring retrieval.
It should be going to do the ring retrieval.
Okay,
Yes. So the ring retrieval is underneath. It's underwater, so you can't see it. But
So
it's
that's
beneath
the
the two-tone buoy.
Yeah.
Which we like. That is orange and blue because those are our school colors.
Oh, okay.
So what we call the Grinch will lower down, and then we'll start to spin, and it will spin. So and as it rotates around the buoy while facing the buoy, and with the intent that we pull rings off of the underwater ring challenge and hopefully collect them to the surface.
Now, how far away from the buoy does the vessel need to be in order to be in the right distance for the Grinch to do its job?
For the Grinch to do its job, the Grinch is located on the front bar of the vehicle, and its hooks extend approximately 12 to 30 inches or so. So it has to get pretty close. The buoy has to be right up in between the front pontoons of the vehicle.
Okay, so now what we're seeing is that the buoy is in between the two pontoons.
Correct.
So it's in the position, right? And now it's sort of starting that spin that you just described.
Yeah, so the Grinch has been lowered. If you notice, the vehicle backed up.
Right.
That's because the way we lower our Grinch is with a winch. We just release it and let it fall down. So to make sure it fell down all the way, we back up to kind of swing it up or swing it forward, and then we drove forward, and then.
So you were actually, when you backed up, you actually deployed the Grinch.
Yes. It looks like our run has ended while we were partially through rotating around the underwater ring challenge, and we hope we collected some rings, or at least knocked some rings off. At the very least, we attempted the challenge.
Yeah, no, that's great. So, okay, so what is going to be determinant of your score would be whether this run, which attempted the ring, is better than the run that you did previously, which was the scan the code and go through the obstacle course.
Correct. That will determine our final score.
Okay.
But we wanted to. We're really happy we tried the ring challenge because no other team has done so, or we believe will do so, and we wanted to do that to show that we could.
Great. So I'm impressed. I mean, I'm really, I'm counting on you. I'm watching you guys. You guys won last year.
We did.
You guys, I want to see if you guys going to reprise that championship.
Yes, I graduated this week, so I'd really like to end school on a high note, my university career on a high note.
So tell me, in what role are you going to play moving forward with this?
Yeah. So our alumni have a history of continuing to be in communication with our team. Definitely socially, and often with advice on selecting parts and algorithms and how to design things, because they're now in an industry where they can learn from people a lot more experienced, and they pass that back. So I hope to when I move on in industry, hope to continue to be able to support Mill and give them advice.
Now in terms of the teams, the way they participate in the actual development of the vehicle, and then the alumni that have already been a part of it and graduated. I mean, how hands-on would the alumni be? Pretty much hands-off?
No, I mean they've scattered to all corners of the nation, so it's more of like asking advice, and then occasionally they'll help us with design reviews. So they'll say, well, we designed this thing, we're not too sure if it's going to work. Can you take a look at like our circuit board or CAD design or something like that?
Now, is there a faculty member or somebody in one of the labs that sort of is the connection or continuity through the years?
Yeah, so I completely forgot to mention him, but Dr. Eric Schwartz is our faculty leader of the lab, and he's been in Mill since he started at UF, which was, I don't know, in the 80s or something.
Oh, okay.
And
he probably started it 30 years ago, right?
Yes, he did his bachelor's, master's, graduate degrees at UF while in Mill, and then he became the leader of Mill. And he runs the lab to be a place where undergrad students can come, or undergrad and grad students can come and build robots and have fun and compete.
Wow, no, that's great. That's
and
great.
He gets us the money we need to do so, and helps us come out to Hawaii. And he's all about us learning. We're learning a lot more than we learn in school by working on things like this and really setting ourselves up for success later.
Yeah, no, that's impressive. That's impressive.
I just got word that we got 2 rings.
Oh, 2 rings.
And we showed that we recovered them. Not sure how this is going to work out point-wise. It would be great if we did it during our big run. But the fact that we've done so and another team has done so is really incredible.
No, that's great. That's great. Now, was the ring retrieval part of 2016?
It was not. In 2016, they had an underwater vision challenge.
Okay.
Unfortunately, the water was too cloudy in 2016 to see very far at all, so no one was able to do it. In addition, the obstacle course wasn't really attempted in 2016 either, but it was adjusted for this year, and a lot of teams have been doing it. So the underwater ring challenge is new. They want this competition to be all about systems of robots interacting together. So by encouraging the underwater ring challenge, they encourage teams to build submarines that work with their service vehicle. Of course, we worked a little bit around that by not using a submarine, by using the Grinch, the ROV, but we're still very happy that we're able to both work above water and underwater.
No, that's great. So that's I think a recognition that you folks can go down in history. You got the first ones to accomplish the ring retrieval.
Yes.
Now I would have wanted to see the detect and deliver.
Yes, and I would love to see totems. That's a challenge.
Now, when you did the qualifying rounds, you did the detect and deliver, right?
Oh, we did not.
Oh, you did.
But we did do totems. We did. We were one of 2 teams that completed 6 qualifying challenges. We did the underwater ring challenge, obstacle course, scan the code, the dock, and the entrance and exit gates.
Okay, great.
Yeah.
Well, I do want to thank you, Matt, for joining me and giving me the rundown on all the inner workings of the University of Florida, and I really wish you a lot of success. Now, which one? Now, let me ask you, just candidly between you and me. I mean, which run would have gained more points? Do you think? I mean,
I believe the the run where we ended on the totems probably would have gained more points,
Yeah.
but the run we're happiest about and most proud of is the
ring retrieval.
is the ring retrieval
Yeah.
round. Yes.
All right. Congratulations.
All right. Thank you very much.
Thanks
Bert.
a lot.
Have a great day.
All right, everybody. So we're getting ready for the final run. We've got Embry-Riddle, and this is the 5th team that qualified for the finals. And you are watching, courtesy of RoboNation, the Maritime RobotX Championship for 2018. And we're really happy to see all 15 teams make it to Hawaii, and the 5 that made it to the finals. We've just gone through all of them. So now the Embry-Riddle group is ready to get started, and I've got a couple of guests here. I've got Vladimir, and what, you go by Vladdy?
Yes,
Vladdy. And then we also have Jefferson, right?
Yes, that's correct.
And then so they're going to be also on the mics talking about what's happening with the Embry-Riddle team here. So Jefferson, why don't we start off with you and tell me, so are we in autonomous mode?
We are in autonomous mode now, yes.
Okay, so what is the team now tasked, or the vessel now tasked to do? Has it already listened to the beacons?
For this run, we're not actually listening to the beacons. We went ahead and went through a gate, though.
Oh, okay, wait, but doesn't the beacons tell you which gates to go through?
It can. You can get more points by listening to the beacons, yes.
Oh, okay, so you just decided to forego that?
That's correct, yeah.
Why waste your time on that small stuff, right?
That's correct. Yeah, it takes some time to deploy our hydrophones, and we'd like to time in our runs.
So. Okay. So, given the course, what have your team decided to be the sort of like the important task to complete?
Our most important task is, of course, the entry and exit gates. The scan the code we're pretty confident in.
Okay.
Yeah, we're also planning to do the obstacle course and the totems, and we may attempt the dock as well.
Okay. So right now it's in the area of scan the code, and just judging from where we are right now, it's hard to tell whether is it attempting that.
Yes, it'll go around the back side and look at it from the other side. The sun in the west is better for our vision, so we go to the west side of the tower.
Right. Because we're on the other side of that, and the sun is pretty much beating down on our faces.
Yep.
Hey, Cliff, you in my way? Oh. Okay, so right now the vessel is scanning the code. It's going to have to transmit basically what it sees back to the team, right? The judges, right?
Yeah, it's still looking at the tower. It hasn't reported yet, so we'll see when it reports.
Now what we're looking at right here in the broadcast booth is what program are we looking at? I mean, is this only the judges can see this, or the team can see this, right?
So this is an interface that we actually built for the judges.
Oh, okay.
So that we can have good communication with the judges and tell the judges exactly what the boat is doing and what it's seeing.
Well, that's cool. I haven't seen that with any other teams. I mean, you guys built this?
This is a Team Minion special.
So did you guys get any points for that?
We've got some recognition for it. There are some points involved in this as well.
Oh, okay. Well, that's a first.
Yeah.
I think I should give you guys a pat on the back for that one.
Looks like the boat has told us it's blue, red, and green.
Blue, red, and green. So blue. Is that correct?
That is not correct. Nope, it's not correct.
You're right. So it's blue, green, blue.
So they've taken RC control, and we're coming to reset again.
Okay. So now tell me, Jefferson, what actually goes on in the computer that is now trying to determine what the sequence of colors are?
Yeah, there's a fairly complex system in this computer. We have 3 neural networks running in the computer. So that's basically, we've programmed the computer to be just like a human brain, and has neural networks that are trained to look for the light tower. So our lasers can find the light tower, and then it'll tell the camera where it's at, and the camera will look at it, and a neural network will tell it where the light tower is in the image.
Right, okay.
And then another neural network will find the actual panel of the tower, and the third neural network will tell us the color.
Okay, and in terms of telling the color, how many sequences does it have to go through to actually come to the conclusion that that's the colors that are being displayed?
It really depends on the lighting conditions and the angle, and it uses confidences. So if it gets a couple sequences that it's really confident in, it'll go ahead and make a guess. If it has a little bit less confidence in its images, then it'll wait a little longer until it's more confident.
No, in terms of the result that came from the first attempt. Do you think, I mean, why did it misread what the colors were?
There's a lot of factors that can go into that. There can be things in the background. There can be the different lighting conditions, kayakers going across. There could be all kinds of things that could throw off the vision system.
I see. Okay. So it came back. It was in manual mode. It's now in autonomous mode.
It is in autonomous mode. Yes.
Okay. So now it's going to retry that scan the code.
Yep.
Exercise.
It's on its way to scan the code.
And the color sequence from our vantage point is green, blue, green.
Yes.
Now they didn't change that, right? Because that's what it was before.
I believe that's correct. Yeah, I'm not sure if they changed it or not.
Green, blue, green. Okay. So our brain can pretty quickly determine that, right? So now you got to think, how does a set of sensors and computers kind of determine where's that light tower, what's going to be providing the signal, and then what is actually the signal itself?
Yeah.
That's pretty complex.
It is, yeah. The human brain is such a powerful image recognition device that to imitate that is a very difficult task. Very, very difficult.
We're not going to see any singularities happen over here, right?
Hopefully not.
Okay, so now it's kind of in position to look at the light tower. It's probably getting some, readings, probably multiple readings, right? To kind of get a high probability of what the sequence of colors are.
Yeah.
That could be disconnected,
So interesting thing to me is that they know that they're confident in this task, so they decide to restart and also look from different angle. Previously, you would see the boat a little bit, more on the other side of the light tower, and now it's looking from different angle, because of the lighting conditions.
So, Vladdy, you're the embedded judge, right? So you spent a good part of the week with this team.
All week.
Oh, okay.
Yeah, so this is the color code that we get in this nice judge interface, green, red, green. And it was the green, blue, green. So I don't know what they will decide to do next.
Yeah, interesting.
And also one thing that I want to point out immediately is the blue light there indicates the vehicle is in autonomous mode. That is a really nice feature for judges as well.
Yeah.
To be able to tell that the boat is in that mode makes it easier for us. It's very hard to observe from shore in these lighting conditions and this hot and sunny day. But
so that's a good point. I mean, so when the vessel went on the other side of the light tower and is trying to determine the color sequence, do you think the sun might have an effect on its ability to determine whether that's actually a blue or a red?
Oh yeah, most definitely. And the recent advances in machine learning, artificial intelligence with these neural networks, convolutional neural networks, have enabled that the machine can really compensate for those changes in lighting conditions. So they're getting much better. Just yesterday in semifinals, I could not see it from here. Everything was white, but their system was able to detect the color code.
Okay, so now the vessel is still proceeding with the course, right? So is it pretty much just said, okay, so best attempt at the scan the code, and now it's kind of moving on?
Yep. So it's just searching for other things to do right now. It doesn't really know where to go because it doesn't know where the obstacles and all the other elements of tasks are. So it's just kind of searching around to see what it can find. And when it finds something, it'll...
Okay, so in the programming, and you said the sequence would probably be the obstacle course, right? Or is there a predefined? I mean, is it just going to go through the course and just figure out like, okay, I'm going to do the totems now?
Right. So there's not a strict sequence programmed into the code. It's just it looks for the elements. If it sees the obstacle course, there's no prerequisites for the obstacle course, so it can go ahead and do that. But for some things, like the totems, there's a prerequisite, so it needs to see the light tower before it can do the totems.
Okay. So now that's a great point. Now the light sequence predetermines what it's going to do at the totems.
Correct.
Right. So if it got the light sequence, if it got the scan the code wrong, they would perform the totem incorrectly.
That's correct. Yeah. So we'll see how it does on the totems. But right now, it's still searching. It has not yet found a.
Now, if
a task, so.
if my brain was like Spock's brain, right, on the boat, I would probably say, forget the totems. I'm going to go do the obstacle course.
Right.
Now, let me ask you something. Does it know that it did the scan the code incorrectly? It doesn't know, right?
It doesn't know. As far as I know, it did it correctly.
Okay.
So, but it hasn't found the obstacle course yet because it's just kind of getting over to that direction now.
Okay, so now, which is kind of interesting. It went to.
They've taken RC.
Oh, remote control.
Yep, we're back in remote control now. So.
Okay, so it's actually in manual mode now. It's going to come back.
Yep, they're resetting.
Okay. So now, I'm curious. It actually went to the totem and was kind of looking like it was thinking about perhaps doing that. Yeah. What made it decide not to proceed with that exercise?
Well, it was still in its search pattern. It never decided to do the task. It may not have seen it, or it may have decided it wasn't worth it. There's some weighting as far as points in the score. So if it didn't think it had enough time or enough information, then it would have decided not to do it.
Okay, so now we are gonna sort of reset. We're gonna get the Embry-Riddle back here and start the course over again.
It looks like it. Okay. Yeah. Hopefully this run we can get that code correctly. Yeah. Like Vladdy said, that's one of the tasks we're pretty sure we'll be able to get in our practice runs this morning. It did really well, and so hopefully this run we'll be able to get that code correctly.
So tell me, Jefferson, what you were kind of the team lead overall?
Yeah, I'm one of the 2 team leads.
And you said you're aeronautical, right? But you got some electrical engineering background?
Yeah, so my degree is in aeronautical engineering, but as far as this project, I've been electrical, and I've learned a lot of electrical, so that's become my expertise now.
Okay, we're in autonomous mode now.
Yep, we're in autonomous mode.
Okay, so it's going to try to attempt the scan the code.
Oh, they're resetting already. Must have missed something. That was I think. Do we get the record for the fastest run?
Don't give up yet. Okay, come on. Now, in terms of the sensing of the code, right, and the conditions that we're in right now, which, from a human standpoint, it might look like it's pretty ideal. It's nice and sunny and clear day. From a computer standpoint, what challenge is it facing? Is it too sunny? Is it the reflection off the ocean? What's impacting the ability to, make the right code decision?
Yeah, so
determination.
Sun is a huge part. Like we mentioned earlier, if you look out on the course, the sun's getting lower in the sky than it was earlier, and
right.
And if you look out at the obstacle course, you wouldn't be able to tell what color those buoys were because the sun's right behind them, and they're just silhouettes. And so you have that problem with the buoys. It's hard to tell what they are. That doesn't affect our LiDAR though, so our LiDAR can still tell what those are.
Now, do you think, like the first run, you tried to read scan the code from the right side, and then on this last effort, you tried to do it from the left side. Do you think? They were both kind of incorrect, so it doesn't seem like either side is being any helpful.
Yeah. So the first time was actually on the back side, and it looks like they're going to go ahead and try the farther right side this time.
Okay.
We'll see if it can get it better.
Now, who designed this interface? This is a pretty cool interface.
Yeah, there were a couple people on the team that designed this. James and Grady and DJ all had a strong hand in this, as well as Marco.
And what is it developed in? What did you guys use to develop this?
This is actually developed in LabVIEW. We're looking right now at the map, and it's actually telling us exactly where the boat wants to go. It's telling us the path it's planning to take, and shows us where it's at on that path. So it helps us to really see what it's doing. It looks like it's just transitioned to the scan the code task. So we're looking at the code right now.
Now this interface that you're showing me, is this available over the web, or is it something that is a standalone? Standalone application that people have to have some connection to the boat itself.
It's a standalone application, so this is connected to our wireless network.
And then over the wireless network is all the information that's informing this application what's happening out there on the ocean.
Exactly. Yes.
Okay. When are you going to put this on the web so I can watch at home?
Coming soon in
2020.
Okay,
let me know. Let me know because I want to see.
I think that would be a really cool feature to add.
Yeah.
Web connected Internet of Things is a really big thing. It'd be cool if this boat was one of those things on the internet. Yeah.
And then people can watch the live cast, and actually, if they wanted to pull up an extra screen to see what the course looks like and the performance of the boat, wow, that would be awesome. Okay, RoboNation, that's the next thing you have to do is get this application live online to supplement the webcast. Okay.
Looks like it's guessed green, blue, green, which is correct.
Yeah.
So yes,
green, blue,
we got
green.
the code.
Yeah, and it did it pretty quickly. So, hey, how about a hand for Embry-Riddle for getting that code right?
So looks like the north was the golden ticket, approaching from the north.
Okay, so the scanner code, they did a good job with that. Now they are probably gonna move on to the next exercise.
Yeah. So the first color in the code tells us what to do next, and it can either pass on the right side of the light tower, it can pass on the left side of the light tower, or it can circle the light tower. So if the boat is acting correctly, then it's passing on the right side. So,
Okay.
So I guess that must be what green is for.
So now it's sort of entering into the area of the obstacle course.
Yeah, it's entering its search pattern. So hopefully it'll find the obstacle course and be able to do it.
Now from this vantage point, the sun is really bouncing off the ocean, so there's a lot of light noise that's happening off the surface of the ocean, right? So what would the sensors be detecting right now?
Yeah, so the same way the sun bounces off the water, our laser sensors also do the same thing, and it diffuses it so it doesn't bounce back. So actually, the water is really helpful in that way, in that we don't see the water. So our lasers are still seeing all the buoys just the same way, and the lasers are what we use to find the objects. So the sun won't actually affect our search. It should be able to find the buoys just the same.
Okay, good.
Yeah.
Because right now I'm pretty confused because I can barely tell the large buoys from the small buoys.
Yeah, it's pretty bright out there today.
Okay, now as far as the programming is concerned, you could do a diagonal or you could do a kind of lawnmower run. What did you guys decide to take on?
We're hoping to do some lawnmower passes today.
Okay.
Yeah.
Now in terms of the lawnmower passes, what would be the thing that would get you the most points? Is it going multiple runs across the obstacle course?
Yeah, the more lawnmower passes, the more points we get. So we're hoping to do as many as we can.
And in autonomous mode, what's going to determine how many runs will it do? I mean, will it do 3, 4? I mean, how do you tell it to stop at 5?
It's a timeout. So we know that we have 30 minutes or however many minutes in our run, and so the mission planner that we use, it decides when to time out on a task. So it knows there's only a few minutes left, and it'll say, I'm only going to spend 5 minutes or so on this obstacle course, and so it'll run as many as it can until that 5 minutes is up, and then it'll move on.
So I'm curious, what did you guys program this in? Is it in Python or is it in C, or what language are you using?
It's mostly in LabVIEW, just like the judge's interface.
Okay.
But some of our code that needs a lot of performance is done in C++. So some of it is also done in MATLAB. MATLAB's been a wonderful sponsor. They're a sponsor of the competition, and it's been a great resource for us as well.
So now it looks like it didn't look like it went through the obstacle course.
I will add to this because I spent the whole week with them.
Vladdy,
so it's basically
trying
trying to detect the 3 buoys, those white buoys that are edges of the obstacle course.
Okay.
And before, you won't start mowing the lawn pattern until it does that. So now, about 10 seconds ago started mowing the lawn pattern.
Okay, so now it's actually inside the obstacle course, right? I mean, before. Wait, did it hook a?
Oh, it
did
looks
it hook
like
a
it
buoy?
hooked a buoy. Yeah, it looks like we caught a buoy line. This is a.
Okay, well, let me release it.
It freed up.
It's like catch and
thank
release. That's
goodness.
like catch and
Thank
release. So I get points for that, right? Catch and release.
You get negative points.
Oh, okay.
But 2 points for each obstacle. Two
Yeah.
negative points.
Wait, if you hold on to it, does it get 5? It's ours now, Val.
Looks like I grabbed another one.
What happens when it rotates?
Maybe there should be a task where it just has to grab as many buoys as possible.
10 seconds, but we're going to force you to kill.
Okay.
Okay, so it looks like it's pretty close to that pretty big buoy there.
Okay, reset.
They're gonna reset. As
Okay, so-
people might have heard.
Yeah, it looks like.
James, go this way. So another 90 degrees, positive 90 degrees.
Interesting. So, in terms of the programming that will help it maneuver through the obstacle course, it has to pretty much avoid the buoys, right? And in that last instance where it really was it encompassed the buoy. I mean, the buoy was between the in the middle of the boat, right?
Yeah.
So what do you think happened there?
I'm actually really not sure. This isn't something we've had trouble with all week. Avoiding obstacles is a real strength of Minion. Minion is the name of our boat. Minion's very good at avoiding obstacles, so I'm not quite sure what happened there.
Okay.
Hopefully ittle be able to do a little better this time.
And what's the name of the boat?
Minion.
Minion.
Yep, Minion.
Okay, let us know what you need, Bill. But it's still in the obstacle field. It's supposed to be random. We made it more random.
Okay, now in terms of judging, right? So the judges have judged this run, which included entry and scan the code, and partially through the obstacle course. Is that correct?
Correct, yes. So judges do their observation. So we note what we see, and then after that we compare notes. And there is a scoring scheme. Everything has to be done precise. So people have to pay attention. It's very hard to do it from shore. So some kind of aerial view in future could be very useful.
maybe some drone footage.
Yes,
would be
something
helpful,
like that.
right?
It would be very nice. This is actually Maritime robotics competition. So as you know now, it includes underwater vehicle and the surface vehicle.
Ah, yes.
Mostly what people see is autonomous surface vehicle.
Well, I mean, I think it
But
would be.
the plan is actually, and that's actually a clever design for these guys from Embry-Riddle, because their platform is free for a possibility of installing and launching and recovery of an aerial vehicle.
Right, because the top, all the other boats had devices on the top of the boat, right? So, and this one is sort of all underneath.
Correct.
So you can actually have a little drone on the top.
Correct.
Now, I think this competition should do kind of like an Ironman and do, it's like 3 different things.
Yeah, that's actually right now. I think RoboNation is dealing with permits in this area, being close to the airport. However, that's the intent.
I see. Okay.
When it happened, it was off the path. It was looking at the
Yeah.
Okay, so now it's still is it in autonomous mode? No. Okay. So we're still in manual mode. We're still getting
still in the
set up.
manual mode. I'll describe a little bit their boat. I mean, Jefferson will add to this, but people have talked about LiDAR sensor. You see this in front is a 32-element LiDAR sensor. They have 3 other ones, and they combine the data from all of those in order to be able to detect range to obstacles and also intensity, which is basically object reflectivity, and very useful. When you combine that with camera that has problem in these lighting conditions, you can have a very good detection system. And so right now, as you see, blue is in auto.
Okay, it's in auto. Now I can see the LiDAR rotating, and that has like 16 lasers on it.
That one is 32.
32.
Yep. And there are 3 others on the boat that have 16 each.
Wow.
Yeah, it looks like it's choosing the 3rd gate.
No. Okay, so it's choosing the 3rd gate. Did it choose it because it was listening to the beacons, or did it just choose it because that's the one it wants to go through?
Today, it's just because that's the one it decided to go through.
Okay.
So,
All sorts of things we can do with BRG.
Okay, so now it's going to do the scan the code. Now the code has changed.
Yeah.
And looks like it's red, green. No, I got that wrong. So I got to reset. Okay, red, green. Wait, I can't tell.
It looks blue, red, green. Yeah, there's a blue. Blue's difficult to see in the sunlight.
So the black and the blue are right next to each other.
Black is the kind of reset time for it. So basically, you start looking after black.
Yeah. I need to get some new eyes to detect that, scan the code.
We've got a boat that can do it for you. So
I need an implant. Okay, so did it report?
It's not yet reported. Nope. It's it's still transitioning to the point where it wants to look at it from.
Oh yeah, I know.
It was 3. We went through 3.
You know, I'm trying not to look at the sun, because as soon as I look at the sun, my eyes are going to get, my retinas are going to get burnt out.
Yeah, it sure is a bright day today, isn't it?
Yeah, it sure is. I mean, and my, eye sensors are going to, not going to work.
That's right, and that's a problem for our cameras too, and making sure that we protect the lenses and the sensors.
Well, I mean, and all the sensors, all this electronics, has to be protected from the salt water.
Yeah. There's a lot of corrosion and protection that we need to do.
Blue, red, green should be blue, red, green.
Blue, red, green.
Yeah, it looks like we reported blue, red, green. So that's a success.
Good. Okay. So now it actually does. It performs something as a result of that color sequence, right?
Yes, I believe if the first color is blue, it needs to circle it.
Okay.
I think that's the correct.
Okay, so now it is actually attempting to circle.
It should attempt to circle. Yep. It's trying to make up its mind.
That's okay. I mean, take your time. Of course. There is a time limit. There's a 30-minute time limit for the performance.
Yep. Okay, looks like it's trying to circle it. So here we go. It's going around the light tower.
Okay, so the Embry-Riddle, they're gonna. Are you thinking that they're gonna continue to, let's say, do the obstacle course as a result of this the sequence of events?
It could do the obstacle course. It could go to the totems. It might even go to the dock. We'll see what they're doing.
Okay. Yeah, let's. Oh, okay. Well, the team says that they're not going to do the dock.
Looks like they didn't put the dock in this run. So.
Okay.
Yeah, it's very much about strategy here, because the clock is ticking.
The clock is ticking.
So when you do reset, you actually decide if you're going to remove a task, because you get points if you exit and complete the task in time. So there's a strategy to sometimes maybe remove a task.
Right. So the strategy is, how do you spend the time and get the most points in that given amount of time, given that we're kind of running toward the end of your 30 minutes. Yeah. Okay, so it's circling the light tower. I'm guessing that it's going to go to the obstacle course.
We shall see. Right now it's searching, yeah. So it's in search mode. One interesting thing about this platform is rotating motors. So some people do install additional motors to the side to be able to get that lateral control, which is very important in wind conditions, to do station keeping. Other team members have described that earlier, but Embry-Riddle has actually made motors that rotate, so they can actually at the same time control their heading and also compensate for the lateral wind forces. And it's very useful for scanning the code. You've seen that they were able to look from different sides, and then also especially in docking.
Now, before it starts to enter into the obstacle course, tell me a little bit about Embry-Riddle and what the department is this emanating from. I mean, what's the support structure at the university that really helps support the team?
Yeah, so it's called Embry-Riddle Aeronautical University, so our focus is actually in aeronautics, airplanes and rockets and things, but we have a vast assortment of different things that go on as well, and this project is done mostly through the mechanical engineering department. We have a specialty in unmanned systems, and so most of the faculty on this project come from that department.
And
we have-
Embry-Riddle Aeronautical. I mean, you guys are located in Florida.
Yes, we're in Florida.
Daytona Beach.
Yep, Daytona Beach. It's
You guys,
right on the
do
ocean
you
there.
have a lot of graduates like like working for NASA or any of the aeronautical industry?
Yeah, so Daytona Beach is fairly close to the Space Coast, just about an hour north of the Space Coast, and so a lot of the graduates from Embry-Riddle end up down at the Space Coast working for NASA, working for SpaceX, working for United Launch Alliance and other space things, and a large majority of them also end up working for big aerospace companies like Boeing, Lockheed, Northrop, and the
So
likes.
Jefferson, I mean, so you're what do you see after you're graduating? What do you plan to do?
Well, I'm hoping to continue on to graduate school, so I'm graduating this semester, and hopefully I can continue on to graduate school and keep working on robotics.
Are you thinking of graduate school at Embry-Riddle?
Yeah.
Oh.
The graduate program at Embry-Riddle is really, really great, and there's a lot of wonderful projects and research that can be done. There's a lot of research going on there. So.
Oh, great. Okay, so it's looking like it's attempting to go through the obstacle course, right?
Yes, it is doing the obstacle course right now. So.
Yeah, indeed. Judge's interfaces shows task being avoiding obstacle. Just to add something on my observation of Embry-Riddle, they act as a big happy family. Their advisors are here. They get along really well. And amazing thing about them is they help other teams. There are many occasions this week that they have helped other teams, loaning them their antenna spares, their motor spares, trying to help them at all times. So this is something that is a great about RobotX and RoboNation.
Oh, yeah.
A great spirit.
Well, anytime you guys can help the University of Hawaii, that'd be great.
Yeah, I think they have as well. So Jefferson can tell more.
Yeah, the University of Hawaii put together a great boat, and they were having some issues with our remote control link, and so we helped them solve that.
Oh,
And
that's great. That's great.
They got some great engineers that were able to solve that. So.
Yeah, and then we love to see you guys over here, and of course the camaraderie amongst all the teams I think is a really great thing, and it's exciting to see. And well, it looks like the time is up, but in your determination, how did Embry-Riddle do?
Well, I'm not going to lie, it's not as great as we were hoping to do, but I think we did pretty good. We were able to get the code correctly, and I think we might have got the correct gate on the last run. I'm not quite sure, but...
and you got some points out of
we got some points on the obstacle course. Yep. So I think we did pretty well. We're pretty happy with our boat this year.
I can pretty much guarantee that you're in the top 5.
Yeah, that's right. I think
maybe even in the top 4.
I think maybe so.
Yeah. I'm just guessing here.
All speculation, but yeah, I think we're really hoping for top 5.
Yeah. Well, that's great. So what happens now? I mean, you guys gonna take the boat back and disassemble it at this point in time? And
we'll disassemble and send it back to Florida. So
great. And what in terms of preparing for, let's say, the next competition, what's on the horizon? Is it 2 years from now, or is there something in between?
The next physical competition is 2 years from now. There is a virtual competition a year from now. But in the meantime, Minion will see a lot of activity. Minion's an active research platform. There's at least 3 different research projects on the boat right now through the Navy, the Office of Naval Research, and so there's a lot of work that's being done on Minion in between competitions.
And as far as the team goes, is the team going to continue to perhaps improve some of the systems? Like, if there's a challenge with going through the obstacle course, or maybe we never did see anybody actually complete the totem. I mean, what can you do now to perhaps improve on those systems?
Yes, so from 2016 until now, we've really redone our vision system and improved it vastly. There's a little bit more reliability and training to do on it before we can rely on it 100%. And I think that's one of the big reasons that we did not complete the totem task today. Is our vision system it doesn't always detect the color of the buoys. We can find the buoys, but detecting the color can be very difficult, especially in sun conditions like this.
Yeah.
So that's one big project that'll be worked on in between, and we've already got a meeting planned in January to start again and figure out what improvements to make next.
Very good. Well, I'm really happy to have you both, Jefferson and Vladdy.
Yep.
Joining me and talking about the Embry-Riddle team, and you guys did great. I think, like I said, I guarantee top 5. Laddie?
Yeah, I agree.
Okay, well, great. So Well, thank you for joining me, and thank you for being a part of this great competition. I want to thank RoboNation and the great effort that they put on to have this competition in Hawaii. This is the Maritime RobotX Championship 2018, and we are hoping that something happens here again. We'll leave that to others to tell. But we've enjoyed all of your guys' presence here and the participation. I want to thank all the teams for being a part of this competition, and it was a great fun.
Great, thank you very much. This was an amazing event, as always. There are many different competitions around the world, but this one is very special.
Yes, thank you. We've really loved participating all 3 times now, and we can't wait for 2020. So.
Yeah, me too. Okay, thanks everybody.
Are we off? We all down? We're off there?
I did, I'm coming.
He's top 5, to be top 5.
Get it? I was like, come
I said
on, laugh.
agree, I don't need to laugh, I just say I agree,
Thanks, buddy.
Hey.
You're amazing. Thank you so much. Next time we'll get you some more
Thank you
shade.
so
Oh,
much.
yeah, thanks.
All right. I got notes for next time. More shade.
Yeah.